Good afternoon, everyone. Welcome to day one of your Gitlab session under the mentorship of the Senior Principal IT Consultant, a TEDx speaker, philanthropist, and the world record holder, Mr. Vimal Daga. I'm sure many of you all have done many training programs under his guidance earlier. This is not the first time you all would have been interacting with him. So it's a humble request that everyone, if you have your friends who are a part of this program, so all of them can quickly just tell all others to join this. We'll be starting at sharp 2:10 to 15. Vimal Daga sir will start delivering from that time. Just before that, for the ones who are interacting with us for the very first time, there are certain norms, criteria which we follow. You all would be a part of the WhatsApp group, wherein you'll be getting the session links for the same. At the same time, soon the technical volunteers would be allocated, who will be helping you through this journey, so that if you have any technical queries, that can be raised out there. You all are a part of different programs altogether. Few are from MERN, few from EARTH, few from specialization in DevOps, and few have registered for GitLab separately. So your respective WhatsApp group will give you the details about the sessions which will keep happening. Tomorrow's session link will again come in that WhatsApp group itself. Okay. Other than this, you will be having an access to a learning portal. I'm sure many of you are familiar with that process. In case if you're not, my team will get in touch with you all very soon by dropping a WhatsApp message for the same. Just to give a brief introduction about your mentor, because it is always good to know your mentor well. Very popularly known in the industry as an integration guy, the one who knows multiple technologies. Companies have got benefited with his consultancy services and knowledge, like companies like Amazon, Google, Microsoft, all the top Fortune 500 organizations, including the banking sector, IT sector, all of them have got benefited with his knowledge. We are blessed that he'll be here with us, and he'll be actually sharing his knowledge, his experience, his tips and tricks, everything practically for GitLab, which is one of the part of CI/CD. GitLab is required for being, in case if you are in a DevOps domain, or even if you're into any IT domain, GitLab today plays a very vital role. Okay. We'll just take a break for 5 minutes. It's not a break. We'll just wait for Vimal Daga sir to start the program. Before that, in case if anyone has any management related queries, the chat box is open, can raise the same and I'll be happy to help you all. I'm again repeating, if anyone has any management related queries, can please drop it in the chat box. I'll be happy to help. And then I think at 2:15, Vimal Daga sir would start his technical session. Ankit has just mentioned that, ma'am, please say, God bless me, need blessings. You'll always have Ankit from mine and Vimal Daga sir's sides. Our blessings are always there with all our learners in whichever form you are proceeding further in your life. Don't worry about that. Prakhar, if you have to leave for your college placement, you can just leave. I'll ensure that the same will be provided to you so that you can go through the same. Dolly, if this is your opinion that whatever you're learning right now is not relevant, then I think you're not in the right program. You should drop this program right away. Then why are you attending your sessions right away, Dolly, out here? Because if you feel that learning MongoDB in the morning hours is not relevant, or learning DevOps as a combination with MERN is not relevant, then you should not be here. Because I'm sure you are very much into that, that सिर्फ placement के लिए जो पढ़ना है वो पढ़ लो and just get through everything. We are not that organization. We are that organization who goes in depth. You study each and every topic in detail. Even if you talk about HTML, CSS, JavaScript, the way Vimal sir teaches, I don't think you will find it anywhere else, is what even everybody is agreeing out here. Even MongoDB, the way he started, if you wouldn't have learned MySQL, the concepts of MongoDB wouldn't have been that easy for you. Also, Git, GitHub, and GitLab is necessary if you really want a good placement in a good organization and not a support-based organization. I hope I've answered everything for you for now. Yeah. Under #13 portal, Satyavir, Arya, you need the access for Git and GitHub videos. You're unable to play them because of the permission issue. Satyavir, my team, we'll drop a WhatsApp message today. Please fill that form. We'll check your access again. We have given the access to everyone for Git and GitHub. It's a humble request to just ask the queries related to this program. I'm not going to answer for DO 280 right now, Naman. You can raise your query to me separately on my WhatsApp message. I'll be happy to help you out there. In my organization, we have started using GitLab. Lucky to get Vimal sir's GitLab session. Great, Amit. Maximum of the organizations have started using GitLab now. And if you would be the few ones to know GitLab in depth, it will give you an added advantage, be it for your placements or be it in the organization in which you're already working. That really helps. Knowing those technologies which others don't know, knowing those technologies which the industry is adapting is always a benefit, be it from a placement perspective or be it from a person who's already working, getting promotions or a better organization or a better role. Okay, which is very difficult for these many of them out here to understand that why is it important to understand every technology, because until unless you integrate, until unless you mix all these things, you'll never be able to stand in the market with something exceptional with what you are. If you really want to be that one person, जो बोलते हैं ना भेड़ चाल चलते हैं, then I think one amongst them are few of out here. Everything is great session technology, Vimal sir. Thank you so much, Gyanraj. Even Prometheus sir has taught so wonderfully in depth. I was able to solve queries of my friends in Prometheus. Amazing, Ashish. Keep going. Do a MERN learner get GitLab training certificate separately? Yes, Abhishek, you'll be getting this certificate separately other than your MERN certificate, because having a certificate of some technologies of DevOps like Git, GitHub, GitLab, Docker, Kubernetes will help you in your placements much better. So we will ensure that we give you that as well. It is super Prometheus session, sir. Thank you so much, Gyanraj. Hats off to Vimal sir, who has been teaching since 9 o'clock and again ready to teach for 4-5 hours continuously. Pratik, this is your love, blessings, which gives him the source of energy to continuously keep teaching one after the another. Vimal sir is the greatest mentor in the world. Thank you so much, Prashant. Thank you. Guys, just one thing on a very general note, specifically to you, Dolly Chauhan, I would like to speak to you on a personal front over phone as well. If you follow what industry follows, the regular pattern of other organizations just teaching you the basics and making a simple project and moving out of a training program, that will never help you in the industry. I'm sure you'll not realize it today because today you're doing it just for your college project. You're not thinking from a bigger perspective, correct? But the ones who are already there in the industry, the ones who are there here from 15 years experience, is what you can understand that, the importance of how Vimal sir teaches, the way he teaches, how are these technologies required in the industry when they work and how do they outstand from others. So Dolly, I would really like to speak to you personally that, how do you relate with what is important, what is not important? I've never seen someone teaching MERN in such a way. Hats off to Vimal sir. Thank you so much, Abhishek. MySQL certificates are in process. We are getting it verified. I think coming week, we'll be circulating all of them. As a Earth learner, can we get a separate certificate for GitLab? Yes, you all will be getting it. Can we know the new MERN stack batch? Vimal sir doesn't start a batch in 6 to 7 months before. So he needs another 7 to 8 months for the next batch. Hats off to Vimal sir. Because of him, we are able to change our future. Thanks, LW. Thank you, Ankur Soni. Dolly, I'm not talking to you. Don't worry about that. When will the MongoDB class be uploaded? As I missed, it will take 24 hours for the MongoDB session to be uploaded. Fine. I think Vimal sir is here. So would like to pass it on to him. Thank you so much, everyone. And over to you, Vimal sir. Thank you so much.
Hey guys, welcome from my side. This is Vimal, and would like to welcome in this very unique program of GitLab, right? So I can start with this one single term, right? About the GitLab is it is one of the very unique product, okay, unique product in the DevOps world, or I can say in CI/CD world, that is. They say this is the one DevOps platform, right? So there's a key term behind the GitLab, right? So what I mean by one DevOps platform, that's what we're going to explain you in some time. But anybody who ever work on any other DevOps tool, mostly DevOps is a big term altogether, but be specific. If anybody work on any CI/CD tool, okay, maybe one of the famous one would be Jenkins or Circle CI or Travis CI or Team CD and something like this, right? They are not one single unified tool, or they are not one single tool where we can do everything. Okay, there is one central piece, and using those central product, for example, Jenkins, we have to integrate different tools for respective use case and the requirement. Okay, so what I mean by this, we will see in very detail. Okay, those who know, I just want to also, try to give the summary and some trying to give a difference between Jenkins and other tools with GitLab, right? But it is a very unique tool. If I just talk about the GitLab, it is one single tool, one platform for all. So whatever activity you want to perform in CI/CD world, okay, from CI/CD world to managing your code. This goes SCM, to build, to test, to do code quality checks, to do security compliance, to do deployment, right? To do monitoring, or to get a feedback back, or you want to collaborate with the different teams. Almost everything what you need in complete workflow of your project and software building, okay, can be done by one single platform that's called GitLab. Okay. Or I can say in simple terms, the entire CI/CD pipeline you can do and complete with the GitLab. That's also one of the way to explain this concept, right? But before I proceed, let me very quickly, I think Preeti have already introduced me, but this is a new batch from my side. Okay, and some of the guys might be joining first time and learning under me. So this is very typical way I always introduce me without investing much time. Okay, if you search my name Vimal Daga, and you will find the information about me, which all area and domains I have worked on. I can say in a technological or IT field, almost whatever possible things is possible in the IT world, from quantum computers to DevOps to blockchain to security to networking to cloud to big data to machine learning to software development, mobile development, IoT, whichever Web3, cryptocurrency, all the things I've worked in my career with almost all the tools. Okay, from monitorings to DevOps tools to hundreds of different tools I work in my career, implemented, certified, plus also deliver, implemented, or done multiple corporate consultant and training also, right? But DevOps is one of my core area of my career. Done multiple DevOps work on multiple different tools of the DevOps. DevOps is big world. Okay, but this training is more about CI/CD. So a lot of CI/CD tool I've worked on, from Bamboo to Circle CI to TeamCity to GitLab to Jenkins, a lot. So I know the core difficulties that you face in some tool that can be solved with other tool, what things one tool can do, one tool can't do in the world of CI/CD. But the conclusion would be the way we work in the real world nowadays, we want things to be very much scalable. I want one thing to be quickly connected, the multiple components, so we can start working on our projects. Okay, so if you work on any other tools, then having your setup ready or connecting to multiple different components or multiple different platform is big challenge. Okay, technical guys, we can do it, but it takes some time to connect the different tool, integrate the different tools, and then only we can start focusing on our in our software development, right? But GitLab is a one tool that's nowadays become very famous, because of the way they create one single developer for everything. That's give you very unique facility or the benefit. Okay, to compare with the competitor of the GitLab, right? So what I'm trying to tell you guys, let me explain you from very zero, because I feel a lot of guys are very new in the world of DevOps in this training. So I would like to start the things from very zero. So for this program, there is no, as such, there is no prerequisite. But yeah, if you know a little bit about Dockers, okay, that will give you a lot of benefits. Why? And when I start setting the GitLab, then you guys come to know why I'm talking about this. Okay, and that is one of the reasons I think in your learning portal, we have already shared the basic Docker videos. I'm not asking to have a detailed knowledge of Dockers, but if you have basic knowledge of Docker, that is more than enough to understand a lot of internal concept, how GitLab work behind the scene. Okay, lab work behind the scene. So I'll just keep on addressing in some time. So this is only prerequisite or basic concept of Linux commands, maybe sometime we're going to use. So that is again as a basic prerequisite, right? Otherwise, as such, there's no other requirement. If you have knowledge in DevOps or not, we don't require. And if you know CI/CD, there is continuous integration or continuous deployment or the continuous delivery. There are two different terms. If you don't know, doesn't require. There's a concept called pipeline we're going to discuss here. And there's one more thing, it's called pipeline as code. That is again very, very required to know, because the core idea behind the GitLab idea means the way we are going to set up the CI/CD pipeline is with the help of code. Okay, so I'll explain the entire code and the syntax in very detail from very basic to advanced. Okay, as we progress in this program. Okay, so technically there is no requisite or prerequisite, I can say, to learn any other concepts of the GitLab. Yeah, one concept is a prerequisite, and that is very much required to know, is Git and GitHub. Okay, so I want at least intermediate level of knowledge you should have about Git or GitHub. Okay, and that video, guys, I have conducted one advanced batches of Git or GitHub some month back, and this entire course we have provided to you as from our side, maybe as a free, and we ask you guys to go through these videos. So if you have a good knowledge in Git and GitHub, it gives you a lot of benefit and learning this concept of GitLab. Okay, so any concept related to repository or HCM or branching, merging, okay, I am not going to obviously discuss in this training. This is a prerequisite for this. But whenever we need, I'll give you very quick information, 1 minute as a summary. So those who by chance forget this concept and might by chance doesn't understand or doesn't have gone through this video, they will quickly connect the concept what we are going to deliver there. Okay, so basic Docker, GitHub level of knowledge you should require to know, understand this tool or the platform of what's called GitLab. Okay, otherwise there is no requirement. I'm going to start things from very zero. Most of the guys might know already CI/CD, but I will have to again start CI/CD discussion from very zero, but a little bit quicker, because we don't have to go much in depth to start the GitLab. Okay, so let me first start this sorry, this concept of CI/CD. But if you see, guys, this tool looks very much powerful, used by multiple different companies. Okay, there's a concept called DevOps pipeline. They say everything has been automated. One single tool, they can do everything for you, from planning to managing and protect and monitoring, configure, release, everything they will do for you. What are those things we will discuss in some time. Okay, so all this capability and the features, what they're talking about of this product, everything we will see. Okay, so how to use GitLab? Okay, these things we will discuss in some minute. Okay, how to get the account, how to use this product, we will see. But let me first explain you very quickly the CI/CD, because GitLab is a product or the platform that is a part of this training, and this training is completely on GitLab. This training is not in the GitHub, and this training is not also the part of GitOps also. Okay, GitHub is different. GitOps is a different part of it. This training is will focus more on GitLab. Okay, and that is your actual CI tool, mainly CI tool, but they have a capability of CD also. But this is mainly the CI tool, but something of CD we can also do. Okay, so what is CI/CD? So let me explain this concept in this way very quickly. What is CI/CD concept and the pipeline? Okay, for example, let's say we have some idea come up, or maybe some project come up from my other company, and we have to build the project, right, or the product from some idea, and the requirement come up from my clients maybe, and we are into the software development right company. So this idea come to us, and based on this idea, my developers or my software developers start writing the code. Let's say they want to build a web app. Okay, want to build the web app means website, And for building the website, they will choose whichever language they want to build the website on, maybe in Ruby, maybe in Java, maybe PHP. Let's say they think let's do building this website on the Node.js, or maybe sometimes also on Node. So they pick the language called Node and start building the web app. Okay. And now it's good practice mostly to, after we write the code, and if they feel the code is almost, one of the main part is almost completed, or maybe they're sitting in their laptop, and one of the part of this code is called, one functionality of this code has been completely is done, and they locally run this code, test the code locally. There's no error as such. Okay, so this code with this kind of functionality they have with this code, maybe welcome page, or code maybe login page, or whatever the what functionality they have put in this code, and after the code is working fine, so they can share this code or store this code, okay, somewhere in the some centralized code management software, code management system. It's called SCM. Okay, so whichever code software management system as a one kind of product or the platform you want to use, you can use. But most famous in the market is called GitHub, that you guys know. Okay, we can store there. Okay, we can store here. Why I want to store this code? So that, okay, other team, maybe I'm sitting in my laptop in my city. Let's say I'm from Jaipur. I'm sitting in my laptop. Okay, and other guys, okay, sitting in their laptop belongs to my team. Okay, let's say I'm Vimal. Okay, I'm sitting in my laptop. My team who working on the same project on this requirement idea, Melson, maybe named Tom, belongs to a different city, sitting their laptop. So they can download my code from the centralized location. Okay, and they can use this functionality. They maybe can check this code, do some changes in this code, maybe use this code with their code. So depending on what the plan will be. So main point is two different member, one single team. We would like to work together. Okay, from work from home kind of way, and in that's called in collaborated way. So if you want to collaborate together, so what you are doing, what Tom is doing, we can have some centralized code management system to work on. So you can use GitHub for managing your code. Okay, and wherever guys you managing the code is called repository. Repository is like a one folder. Okay, so we can put the code in this repository in the GitHub. But mostly guys, GitHub as a platform, you guys know, is a platform available in the market, and it has been used a lot for the open source world. So any new project start in the open source world, a lot of guys start coming and launching the code, putting the code there, asking openly as open source to start contributing. Okay, so nowadays this GitHub is more look like as a platform for connecting the or collaborating the open source kind of things. Okay, but if you are working on a project, on an idea that is belongs to your own internal company, and you want something that is belongs to you, where you have lots of internal controls. Okay, or GitHub is like a cloud-based solution. It is like a SaaS, software service, like cloud-based solution that is been hosted by somebody. You have to deploy the code here directly. You deploy the code or data here. Okay, but everything is been internally managed by GitHub guys in terms of internal what feature they want to add and remove. Okay, issue management or pull requests or merge or what other things they have to do. Whatever they have provide, you can use it. Okay, but if you have a more granular control, and you want a platform where that has been look more for you, for your company, for your team, for your project. Okay, again, you can think GitHub is like a more shared based or open public based. Even though in the GitHub we have way, whatever repository we created, we can make it private, means nobody can see in the real world, but some more things we can do if it's for in terms of private or security. There's different point, but it won't give you that feel that is owned by my own company. This is like a, the way you work in like on premises kind of thing. Okay, Git is like a public open. So for example, if I'm working in my laptop, what I keep in my laptop is like a private. It's my own premises. The kind of feeling GitHub don't give you. Sometimes we need it. Okay, especially if there's some kind of very critical code development is going on. So we need some kind of isolated environment, or we need some time of on-premises kind of environment that is not given by, as such, not by given by GitHub. Even though we can add some security like private, but it's not given by GitHub. So as a SCM tool, GitHub is very famous, no doubt. Okay, but when the point of on-premises is gonna come up, okay, and I want to host my own, other way we can say host my own HCM platform for managing my code, or do a collaboration between different team members. We can share the code, work together. Okay, that is mostly also known as continuous development. Okay, GitHub won't be so much useful. Okay, so in this case, there's again a lot of tools available, but one of the tools that you can use that can work exactly like GitHub, that can give you almost same look and feel that GitHub give you, something like this, or GitHub give you. That's most very simple to use, plus more advanced features in terms of security, and they give you feeling of on-premises, where you can also host your own repositories. Okay, where you can host your own repositories. Okay, isolated or on premises, I can say. Repository means what the way GitHub provide to you. That is can be done by GitLab. So GitLab is a different product altogether. It's not part of GitHub. GitHub is a different company, different community. I believe it's been now taken care by internally by Microsoft. I believe, if this is not wrong, GitHub. If you just search in the Wikipedia, it has been now parent organization becomes Microsoft. If you talk about GitHub, it's a different tool. Okay, 5.2.8, but the main motto of GitHub is just to HCM. Okay, software control management has been now taken care by, taken by Microsoft. That's what I'm trying to tell you. But it's not about company. My point here is GitHub is more like for open source guys. Okay, but if you want to get a feel of on-premises, if you want to, I can say, or host your own repository, or have more secure environment like a private environment, then GitLab can be one of the SCM tool you can use. Okay, this is one of the small point of GitLab. GitLab is expand, can do much more thing, but if you search for GitLab, okay, and GitLab is different name is by chance GitLab, but is owned by GitLab and corporation. Okay, by these guys. Okay, that's the different company altogether. A lot of guys been normally confused with GitLab and GitHub. Why is the different? These guys from Ukraine. These guys have created this corporate company called GitLab Incorporation, or maybe Incorporation companies. Okay, the one thing. So one thing out of GitLab, they give you as a difference, obviously more difference. Even though technically it's not good practice to compare also, because GitLab is a DevOps platform. GitHub is mostly code management kind of platform, right? But yeah, this is one small difference. GitLab give you that capability of hosting your own premises repository, something like GitHub. Okay, where you have entire control whatever you want to do. Okay, this is one thing in the GitLab we have. Now, let's say after the code has been uploaded in the any of the SCM tool, maybe in the GitHub, or maybe in the GitLab, or maybe in other SCM tools. Okay, maybe Perforce, or maybe SVN or CVS, whatever would be you're using here. But after you upload the code, okay, what you have to do? Okay, some of your team member, okay, somewhere sitting in the other laptops, so the team member, they will download this code, Okay. After downloading this code, let's say this code is written in the language called C++ Java. So after they download this code, okay, normally this level, these code guys, normally we have to compile. They compile this code because this team duty is to compile the code and then do something on it. Okay, then run it, test it, maybe there's something like this. Okay, compile the code, or maybe the code written in Node.js, for example. Okay, so after they download the code, and then their duty is to see this website has been properly working or not before we provide the website to our customers. Okay, so again, in Node language, we don't have to compile the code because it's like an interpreter kind of language, mostly written in JavaScript as a language. So here they will do some kind of setup. Okay, maybe in this language we have lots of a library included, so my team will download all the libraries. Okay, and then this code is ready to use in this laptop. So what is use of this laptop, or what is use of the system where this team is working on? Motto is we want to test. It's called testing. Test means because this code has been created by Vimal or work with Tom or 10 more different team members. They work together. Okay, and now they say according to my side, and we are the developer, my code is done, ready to use. Now this code can be delivered to the clients on the internet. They can use my final website. So technically they say from my side everything is committed and it's final. You guys can do. Okay, so there's one client over the internet, right? They can use my application. But before the client use the application, right? Because we can't directly give our code or my website to the client. Maybe we have some bug, maybe some of the part might not be working. So we have some testing team. Okay, they will test the code. But before they test the code, okay, the code written in Java, C++, they have to first compile it, or code written in some other languages. Okay, so the code we will download it, and this team in their laptop will set up the will do respective thing in respect to languages. Maybe they download libraries and some more things, so that this code can be run here, and after we run here, we can test it. So technically depend upon language to language, guys, language to language. But this part, compiling the code, collecting all the libraries, set up some folders, set up some internal files. Okay, depend upon again programming to programming language. Okay, this part is also known as build. So we build this setup in this system or in this laptop. Okay, so that we can run this code. And after we run this code, then only we can test it. Run means, let's say, this website. So when we run the code, then only my website or web app starts. And after website will start, then only we can connect to the app. And why we want to connect? Because I want to test it. Does website working or not? All the path or URL is working or not? Let's say login page. My login page, I'm typing my login and password. Everything is working properly, working or not. We have some bugs, right? All the fields and feature look and feel works or not. So we will do a test. Before the test, we have to run it, and before the run, we have to set up whatever the code require, either libraries, or we have to compile. The code need a compile. Let's go build test. We have to do. Okay. Now in this entire process, if I draw this diagram one more time in 2 or 3 boxes here. So here we have a developer. They upload the code to some SCM tools like GitHub or GitLab. Okay, and one of my other team member download this code. Okay, and downloading is normally called pull, and the upload the code is called push. Okay, after the download, here they will first build the code, means let's say in simple term compile the code, then they run the code. After they run, they test the code. Okay, it's done by one of the team member. This team is mostly known as testing team or testing department. They will do in their respective system or respective operating system. Okay, now point here is uh, this code has been uploaded into, let's say, if we just talk about GitHub, not GitLab, let's say GitHub uploaded here, because it's a very common famous platform we have. Okay, so this is duty of one of my team member. Let's say this is a testing team. Okay, what the duty of this team member? Okay, the first duty of this team member is, okay, first duty of this team member is keep on checking. Keep on checking. Does there's new code uploaded from a developer? Because okay, testing is not one-time process. Because last time when you test this code, you're testing every part, but maybe some other part of my login page doesn't work. Okay, doesn't work. So as a testing guys, okay, some of the part that is not working. Okay, so some part is this called failing and it's called test fail. Okay, you can give reply back. Okay, a reply back to the developer, that is most known as feedback, and say this part and this feature is not working. So again, their developer teams will again remove this bug, update this feature, make it workable, and again the upload to the system. Again, my testing guy will download it. So again they test, again they fail, again this process keep on going. So it's a continuous process. Okay, so that is reason guys, it is I can use the word here, my developer is keep on doing that's called continuous development. Okay, or here this GitHub or this kind of tool is keep on doing continuous source control management, and testing guys is keep on doing this is called continuous building, continuous testing. Okay, because this process is going on, because in the software development, okay, there's a lot of bugs is keep on coming, or there's a lot of new website features keep on adding. So development is keep on going on every time. When the developer done completely, build again keep on going on, and then test is keep on going on. So this everything is continuous. It's called continuous. That's all. Okay, so let's say right now at this point in time, developer upload something. Okay, so this is the duty of this team to keep on checking, keep an eye on this particular area that's called repository, or this folder where the code is being managed. If some new code come up after they added some new feature or remove the bugs. Okay, now this team duty is first to keep having an eye on the repository, and when a new thing come up in my code, it's called code change happen. When the code change happen, then this team duty is to do one thing, is to first set up this OS. Okay, set up this OS. So they will first install this operating system. And guys, again, installing the operating system is not the small thing. Okay, for installing the operating system, we have to get the entire hardware, RAM, CPU, something like this, and a physical hardware. On the top of physical hardware, they have to install respective operating system. Okay, let's say their plan is to build the software or test the software on the top of Red Hat Linux or Linux. Normally, they have to install the Red Hat Linux. Okay, and again, installing the Red Hat is not enough. If the software is built in Java, they have to install Java respective version, which is Java compilers. Okay, or JDK, Java Development Kit, or if the software is built on the top of Node.js, so they have to install Node software here in this operating system. Okay, or their respective other things over here. Then this entire setup is done. Typically, it's called environment. So this team has to first set up the environment. Okay, and why they have to set up? Because good practice and due to a lot of reasons. Okay, if this setup they already used initially in one go after they download the code, and this software has been this environment has been already been used for building and testing. Okay, and if they find some bug, again the update to developer, and developer will rectify the bug, again upload. Next time is good practice, just terminate this particular system and launch a new system. This is called launch a new environment. Why? There's a lot of reasons. One of the reasons may be after developer rectify the bug, that time they might have updated new version of the software, and here this target has been set up with the older version. So next time you check the code, again they fail. Okay, So this is one of the reasons. Otherwise, there are a lot of more reasons. So good practice normally in the testing world, we have to reset the environment or reset up or reinstall the entire environment where we need minimum physical hardware, operating system, and respective interpreter or the compiler of that particular language, whatever the language the code has been built on. Okay, now this is one process. Who will do this process for us? That has been done by the testing team. Okay, and then next thing what testing team will do, they will build the code. I mean, let's say in simple term, in some of the cases, compile the code. Okay, and next case, after compile, they will run this code, and after they run, next thing they will test. Okay, and normally guys, for testing, either they can do a manual testing, means let's say this is a website. Okay, when they run, means this is a web app, right, written in Node, for example. And when they run this app, your website will start, and maybe this website has a URL, so we manually go and check the URL, everything work or not. This is manual testing. But guys, normally in the web app, there are hundreds and thousands of features. If you do manual testing, that's a lot of time. Okay, and some of the part we might miss. And also we have to think one more thing, guys. In this today's world of agile, we want everything to be very, very faster. If you do anything manual, things become slow down, and whatever you're developing, it takes a lot of time. And the more time you take, you become out of your competition market. So we have to take one more thing. Whatever we're doing, it should be very, very quick. Okay. So we don't want to use manual things. So maybe we can ask my developers, okay, or maybe the other team, they can write a code for the testing. Okay. The code is going to test all the feature, whatever I want to test with the mobile phone. That makes the things very much automated. Okay. So the code for writing tests can be done by developers, or the testing guys who are the developer in the testing test environment, or the test team, they can write the code. Okay, but who will run the code? This can be run at this step, at this particular step. So my testing team, okay, after the build run my web app, for example, website, they will run the test. Okay, and in the test, guys, if you're trying to test 10 things, so 10 different, there's called test cases they have to write. Okay, test cases they have to write. But at this area, these are things normally can be done by the testing guys. Okay, but in this entire point, what I'm trying to tell you here is, okay, the only challenging part is my testing guy has to keep an eye on the code changes. When the code change happen, okay, they have to download the code. Okay, then after code downloaded, and before the code download, I can say they have to set up this environment. So how testing team is doing this? Okay, obviously they're not doing it manual, because we don't want anything to be manual. Here the role of continuous integration tools gonna come into CI tools. Okay, because my code is keep on changing, content development, continuous code management we are doing. Okay, or continuous source code management we're doing, continuous build we're doing, continuous test we're doing. But in the build test run or build run test, all right, these steps we have to again we have to perform. Okay, and to perform this step, okay, we can take one tool rather than we do manually, my team do manually. We can take some third-party tool. I think that third key here is a third-party tool they can do for us. What? Continuous integration. Okay, one of the famous tool in the third party is called Jenkins, that you guys might have heard about, or Team City or Circle CI, hundreds more tools we have. Okay, so this team, to make everything automated and to perform all these steps, and some more step in between, more or less, depend on what you want to do. Right, they will put the tool somewhere here called Jenkins. Okay, is it third party tool? Okay. And what Jenkins will do, okay, Jenkins do the same thing what we asked to do from the Jenkins. So Jenkins will have an eye on the repository, and as soon as some new code come up, let's go code change, Jenkins will download for us. So this part can be automated. But before we say, because before Jenkins you download this code, or maybe after this code been downloaded, now this is your duty to set up this environment. So this is your duty to do the step number 2, means setting the environment. Okay, but none of the, as such, the CI tool, continuous integration tool, has a capability to set up this environment by their own. Environment means getting physical hardware, operating system, setting some software over there. Mainly I can say, if you ask Jenkins or other kind of tool, can you give me some RAM and CPU and store Red Hat or Windows operating system on top of you? So answer is no, they can't do, because this is not what they meant for. Okay, their duty is to connect the dots here and there. Okay, so in this case, I've again created a new diagram here. In this case, how Jenkins can be useful here. Again, see the same diagram. Developers we have a SCM tool like GitHub, and here we have the Jenkins. So one thing Jenkins can do that has maybe an inbuilt capability they have any new code come up, they will pull the code. Okay, so first step can be done. My second step, okay, because I want to do build, run, test, I need the operating system, the environment. Okay, Jenkins can't do for you. Okay, for this, you have to tell the Jenkins from where you get the environment. All right, to whom you have to contact to environment, who gave RAM and CPU to you. Here, there's a multiple choice available in the market. It's again the third-party tools. Okay, one of the tools maybe Dockers you can use. Maybe you can use Kubernetes. Maybe you can use cloud platforms like AWS and something like this. So multiple different tools and the platform available for this. Or maybe you can use any kind of virtualization tool, getting the virtual machines like VMware something. Okay, I need an operating system running. Okay, so let's say we ask the Jenkins do one thing. Okay, just contact to Dockers. Okay, and Docker will give this environment to you. Okay, which environment? What I try to explain you here. This environment. Okay, which is a RAM, CPU, operating system, plus inside the operating system, some kind of pre-create installed compilers or the interpreters. So Jenkins will contact to Dockers. Okay, and Dockers and ask Docker, can you give this one? Can you help me to install one entire operating system? They give me some physical hardware plus the operating system plus pre-install some kind of interpreters or the compile. Let's say my code is written in Node, so they give me Node interpreters. Okay, who will give this entire environment? Docker. Okay, this entire environment or the operating system. But who asked them to give? Jenkins. But before you ask Jenkins to give, okay, initially the admin of the Jenkins who set up the Jenkins software in your company, okay, they have to first do lots of things. First thing, they have to install the Jenkins setup to do this part automatically. Which part automatically? This part. Okay, this part, as the code come, automatically the code downloaded. This one, then setting the environment, then building. All the things I wanted not done by my testing team manually. I want this part to be done automatically. That's what the key. I want things to be faster. Okay. So that is the reason we have to install Jenkins here for this purpose. For what? For the automation. But only Jenkins is not enough. Okay, we have to install Dockers also or Kubernetes, whatever you have. Okay, this part. And third is Jenkins, we have to integrate with Dockers. Okay, there's two different tools. Jenkins belongs to different community, Docker belongs to different company community. We have to connect these pieces together. Okay, and all this thing is done by some of my IT admins guys for us. Okay, so it's not, even though those who have done Jenkins training under me, we have done this kind of practical over there. Interesting, no doubt. Very interesting concept it is. Very interesting to know this concept, how this integration work between Jenkins to a third-party tool like Docker Kubernetes also we have done there. So cloud also we have done there. Okay, but the point is we need some extra team for this, who has good knowledge in Jenkins, who has a good knowledge in Docker, they know how to integrate. And sometimes integration is one time, but as we progress, sometimes this integration may be disconnected due to any of the reasons. Some bug come up, some new version come up, some older version doesn't support. So maintenance is very hard actually. Okay, as a knowledge perspective, as IT guys, we always want to learn some new things, but okay, but as a company perspective overall, okay, whenever we have the maintenance cost is high, it will waste a lot of money and a lot of time also, and energy also. Okay, any new bug come in Jenkins, any new bug come in Docker, and how to integrate, that's called plugins. There we have come issue in the plugins to connect Jenkins to Docker or Kubernetes, then system goes down. Okay, and goes down means the entire development process is going on. Okay, build, test, and all things become, we have to stop it, and it will impact finally the business of the company. Okay, so point here in this, if you talk about this point, you talk about this point, okay, for continuous integration, okay, we need a tool, and here the tool is called Jenkins. What I remember continuous integration? Okay, continuous integration means as the developer upload the code, push, I want Jenkins will go and download the code. First step, automatic contact to Dockers and launch the new OS. Second step, okay, after this OS launch, then Jenkins will copy the code here, okay, and ask this code to be built on the top of this setup. This is called build. Okay, then ask the code to be run. After run, ask the code to be test. This is called testing. This is what the guys 5 steps I was talking about. Okay, code launch, set up environment, build, run, and test, and much more step maybe between, right? Or maybe lesser step, depend upon what you want to do. So Jenkins will do all this kind of connections. This is called that's called continuous integration. So integration part continuously can be done by Jenkins, and after any test fail, test cases fail, but some of the part is not working. So again, this is duty of the Jenkins to take this failed report and send back to developer. So they can change, the same process keep on happening again and again. Everything can be automated. There's no challenge in the automation part here in the Jenkins and other tools like Jenkins. But only challenge here is the management part. Okay, who is going to configure Jenkins? Who are going to integrate? Who is going to configure Dockers? Okay, or who is going to manage also in the future if some thing come up? So rather than we as a company will hire one entire team as an IT team or IT operations team, okay, to just manage this part, okay, for our company, even though we have great engineers in our company, okay, but if something fail, it takes some time, right, to solve this particular challenges. Okay, so this is one point. So rather than we focus on the management part or the maintenance part of Jenkins and Docker integration, installing Dockers with a perfect version, because if you're installing Jenkins, you have to check which Jenkins version has a better options. Option means which is the most solid. Jenkins means more optimized way, or means there's been long time term support kind of Jenkins, and which is the right Docker version is highly optimized, which has a proper plugins to use. So lots of things guys you have to take care, right? So my point guys here is, okay, in this CI part, continuous integration part, okay, part lots of things in your company. Let's say my company name is Linux World, and we are more into software developers or software development, web app or mobile app. Rather than we focus, invest our time and money on the managing the operations part. Okay, why not we can outsource this? Okay, why not we can outsource this entire part and somebody on our behalf manage this environment of CI, continuous integration. Okay, rather than we manage Jenkins and Dockers and all the things. Okay, we want to focus more on the coding part, right, and the software development part. That's what my company come. That's what my clients come to me, right? So my client, the way I explained to you here, okay, my client come to us to by giving the idea and the requirement for the development. They don't want, they have no point, right, to discuss that how you manage the entire continuous integration. Their plan is they give you deadline for 5 days or 10 days, 1 month or 10 months. Okay, the software to be done, right, completed. Okay, now you're managing manually with the help of automation. You're managing your own Jenkins. You're putting the Docker running there, not running there. You're testing or not testing. That will be your call. They want their client want their requirement to be fulfilled in some whatever deadline they give to us. Okay, so in this kind of kind of idea. Okay, now you have to think where you have to invest your time and the money to managing your IT operations, guys, or you can outsource this entire setup. Okay, technically, I want my code to be created. I want my code to build and run test. I don't want to skip the steps. So I'm not talking about skipping the step. I need this step to be done. These steps to be done. These are more technically known as steps. These steps to be done. Okay, and sometimes these steps are also known as stages. It's the better term. I want all these stages to be performed. I want to build, I want to run, I want to test. Okay, build and normally come in the same line actually. So build and run is the same thing. Technically, when I say build, mostly build come with a run also. So I want a build stage, I want to run the test stage. I don't want to skip. There's a minimum requirement, or that's what the things we always need. But for building and testing, and connect these dots. Okay, we want to build only when the new code come up. We want to only test when the build runs successfully. We want to send the feedback to my developer with the test fail. Okay, so I want this setup to be automated. We can use Jenkins, but who's going to set up the Jenkins? Who's going to set up the Docker? That was the point. So setup part, okay, we can outsource to somebody, and that somebody can be your GitLab. So GitLab say, now you don't have to worry about, okay, setting up your entire setup of continuous integration part. This setup I have already done in my environment. Okay, my environment, you can directly use it. Okay, so you don't have to use the Jenkins. You don't have to set up Dockers. You don't have to worry about integration part. Okay, everything I give you pre-set up, and my team has already tested, and all the bugs, what are possible things we are maintaining for you behind the scene. Any new issues come up, new version of Docker come up, everything we will provide it to you pre-set up. You have to just use it. Tell me your requirement. Okay, tell me your stages. Stages means tell me, all right, do you want to build? Do you want to test? Okay, do you want any code change to be run? Then only you want this environment to be created, right? And lots more things. So as this guys explain you for the main part also. Okay, I'm just giving you a very quick summary. Over here, those who have no idea on CI/CD, I'm explaining you CI/CD concept also. Especially here till now, I explained the CI part, continuous integration part. But those who by chance know CI/CD already, I'm also trying to comparing you, okay, what you guys know and doing till now, and what extra benefit GitLab can do for you. So conclusion, guys, here is, okay, GitLab is a one tool, okay, who is giving you repository management, For example, if you ask Jenkins, can you do repository management for us? Can you deploy and host local repository? Answer is not. This is not the duty of Jenkins can do. Okay. So can you set up the Dockers for me? Jenkins can't do Docker setup for you. You have to do it by writing some extra code in the Jenkins. A different point, but Jenkins can't do for you. Okay. Or can you ask Jenkins, can you store automatically? Obviously, we have to store Jenkins. Okay. So this entire operations part, and this is again use the word called IT operation part. You don't have to worry in the GitLab. They give you pre setup. Okay, till this part, every part of it. So you can focus only on the development part. Okay, so technically it means we have one single platform. Okay, by GitLab. Okay, and based on the till now knowledge, what they do for you. So as a developer, we have to now just sit in our laptop, that's called workstation, writing the code. Now the same process would be there. We will push the code to the SCM tool, but this SCM, let me write a small box here. SCM can be hosted by the GitLab. So GitLab is one where we can host the SCM. Okay, this is one thing. Now, after this, we want some kind of CI tool, continuous integration tool. Okay, who have an eye on the any new code come up, they will download the code. Okay, pull the code. Again, this CI tool is done by GitLab. One same tool here. I'm just writing different boxes, but it's same account and same tool or same platform, one platform. Okay, and after they pull the code, then based upon the requirement, you have to tell your CI requirement. That's called pipeline. You tell your requirement, what pipeline you need. Pipeline means this is what when I write here pipeline. So do you want to install any operating system? Do you want to build? Do you want to run? Do you want to test? Much more, lesser? Obviously, none of the team or company know this. Neither Jenkins know, neither GitLab know what you want to do it. Okay, what you want to do, what steps you want to perform, or what stages you want to perform. So you can tell your pipeline, means step by steps. Okay, so you can tell here, first thing is, okay, to the GitLab that I want you have an eye on my particular repository. Okay, so this is what I want. Eye on my repository means keep on checking and tracking any code changes. Okay. Second requirement is if the code changes, then I want you will download this code pull. Third thing is after I download, I want my environment to be set up. This is called operating system to be installed. And for installing the operating system, I want you use Docker or Kubernetes or much more platform we have. But in this case, none of the platform you have to set up. Okay, they have almost all the main platform given by them, you can use directly. So for example, you don't have to set up Docker. They have given you pre-Docker installed. You have to just use it. And they have pre-Docker already integrated with the GitLab internally. You have to just use it. In the Jenkins, you have to install Docker first, you have to integrate first to do the remaining part. But here everything is pre-integrated or pre-set up. But you have to tell your requirement, okay, that I want my environment come from Docker and I want to use this environment for what? Okay, I want this environment to be used for build purpose. Okay, you have to tell this. Okay, and after my software build inside the Docker, then they create one kind of package. For example, the software may be written in Java. Okay, so you have to upload Java code, then the build. When you compile, they get one software. The software is called package. Let's say in Java, your website package is not a WAR file. It's extension for the web app or website. In Java as a language. Okay, that package is called software is called package. typically in the development world, instead of software or instead of the package, we mostly use the term called artifact. Artifact is a term normally we use. A package or software is equals to artifact, or web app is also known as artifact. So in say in the fourth step, your artifact has been created. That's what I have to tell here. This is our requirement. Okay. But then guys, this software that you created. Okay. The main thing is the software. So do you want to store the software in somewhere in some centralized location? Centralized location or centralized storage? Okay. Why? Because after software created, my other team can use it, or maybe we can also use it. Okay. So do you want to store this software centralized? Okay. So you can say, yes, I want to store my software centralized. So we can say artifact or my software, I want to store it. I want to store it somewhere. Okay. So in the Jenkins world, okay, in Jenkins world, if you want to store the software after you build, okay, we have a separate tool for this. Okay. And this tool are normally known as repositories or central repository, or artifact or central artifact areas or locations or artifact storage we have, but also known as centralized package management systems we have. So we have different tool for this. Okay, one of the famous tool is called Nexus Sonatype, right? Or one of the tools is called Artifactory. These are third-party tools. Artifactories. Okay, so you have to ask Jenkins after the software has been created, package has been created, upload the software in this Artifactory. Is a tool, is a one tool, by tool. Again, same point is we have to set up this tool. We have to ask Jenkins to connect it. Okay, and then do all the management work here. Okay, or maybe it can be installed in Jenkins local also, depend on how you set up in the Jenkins, or maybe other tools also. But here, okay, here the centralized storage for managing the Artifactory is done by, again, GitLab. You don't have to worry about this operational work again, then be done by GitLab. Okay, or after software installed or software has been stored somewhere in the storage, this is called artifact or software. Okay, we can ask, and the build has been done. Now it's time to do testing. So what are software you have created? First, run the software, and after run, test it. Okay, so that can be again done by your GitLab, and much more. Maybe in between some more stuff we can add. We can remove some steps. I don't want to store. We can remove it. So by this is your plan. Okay, so as a CI guys or content integration guys, mostly this is nowadays these concepts of automations and CI and all the continuous integrations. Okay, all these things come under one name called DevOps. So maybe you're the DevOps engineers. Okay, so this is your plan. What you want? What you want? How many stages you want? You want one stage, two stage, 3, 4, 5, 10 more, 100 less and more. What are the step by steps you want to do in your software development process? Okay, so that is the only thing you have to tell to the GitLab. Okay, because obviously there's things they doesn't know. So this pipeline you have to create. That's what I'm trying to tell you. Okay, just create a pipeline and tell the GitLab, this is my pipeline, and I want this pipeline to be run. That's what. Okay, the remaining part of running this pipeline, the entire operation part, you don't have to worry about it. Okay, everything can be done automated by the GitLab. Getting the entire providing the entire IT operational part is done by GitLab. You don't require to install Jenkins, neither Artifactory, neither Docker, neither integration. Okay, or tons more things they have. As we progress, I keep on explaining the remaining part. I think this, but till now, so you get makes much sense what GitLab can do for you. Okay, you just tell the pipeline, and GitLab will make sure this pipeline to be run. Whichever extra tool they need, extra integration they require, okay, they will do for you to run your entire pipeline. Okay, and pipeline is the one who will actually do the continuous integration for you. Okay, continuous integration for you. So this entire pipeline will be done, and in the last, after the test been run, maybe test fail. If they fail, we will give a feedback back to the developers that some of the test has been done, and they get the feedback very quickly. And interesting thing is, right now mostly developer need for development purpose, they need the ID, integrated developer environment, for writing the code. Interesting thing, guys, GitLab also give the ID to also to developer. So they have their own IDs. So now there's one single platform for everything. So developer use the ID from the GitLab, same ID. They are writing the code, same ID. They're managing the SCM, the scope version controls of the code, VCS, same ID. So same GitLab. After they save the code, automatically pipeline start, depending on what you want. Same ID, they will get feedback, and they will get the feedback on the same GitLab account. Okay, and they start working on the new bug come up or new test fail, happen again, change, and same process happening again and again. Okay, till then the feedback is not up to date, whatever we're looking for in the test cases. Okay, everything can be done in one single platform, and that is the reason why GitLab is claiming that we are the tool of one DevOps platform for all. Okay, I'm taking just Docker as example, but your plan, maybe you want to do something on Kubernetes, you want to do something on a cloud, you want to do something on other platform with the cloud, like platform as service like OpenShift. Okay, or maybe other cloud, let's say Beanstalk or other platform services. Everything can be done in one single platform, because project to project, team to team, we might be comfortable with different technological integration. There's got technological stack. Sometimes Kubernetes, sometimes OpenShift, sometimes both for some purpose, other purpose. Everything has been pre-integrated and connected to the GitLab. When I show this demonstration, you become more comfortable at. But okay, I just trying to explain you how GitLab is again CI tool, continuous integration tool, even though they have option for CD also. What is CD? We'll discuss sometime. This for continuous deployment or the delivery, we'll discuss. This called CI/CD. But right now I'm just focusing on only on the CI part. Okay, because in DevOps, okay, dev means that developer. So developer is more focused on the dev part of it. Okay, dev part means the CI part is normally the covering the dev part. Because as a developer, write the code run, test, build, right? Build or test, and they get the feedback, they again change. So till this part, what I'm trying to explain you is more for the developers, guys. Okay, so as quick they get the feedback, they quickly change the code, and the code can be built very quickly. So in the DevOps world, so till this part means the part of the CI is more focused toward the developers. And after the code built successfully, tests run, the code is ready to go for the real world, for the customer, that is called production. Then the operations team are gonna come in play. That the CD development, deployment or delivery gonna come in play. Okay, so we can use GitLab for this also, but we will discuss in some time. I'm not discussing right now. I'm focusing only for the developer part or dev part of the DevOps. It's called CI part, continuous integration. Okay, so those who don't know about CI/CD, at least not CI/CD, at least they understand what is CI. CD we can discuss separately. And plus those who already know CI/CD, they might have able to understand, okay, the power of GitLab. Okay, and what is the meaning of the one having one DevOps platform. Okay. Now, if you check this area, so you can from planning to production, one bring team together, one application, right? Things will faster. That's what we need, right? Everything. If you Okay, even though guys, this is maybe the good link. What is GitLab? This video I think they talk about. But again, for every stage of DevOps lifecycle, every stages means that's what I talk about. Build, test. These are the different stages. Okay, in one single platform. Whatever the core content capability they do, that's what I'm trying to explain you. We'll go more in depth. Okay, an entire thing from planning to create, the verifies, packaging, release, entire stages of CI/CD can be done by one single platform. Jenkins can also do for you. That's also one single platform. But tool like Jenkins or tool like Circle CI, okay, we have to do a lot of operation tasks. We have to connect the dots. We have to connect the different technology tools. That is very painful in most of the times. But here, everything they have done. So I can say this is a created setup, and that is the reason why they use the term called platform. So this is reason they say one platform and one team. That was one key area, and that is one of the reasons why this tool is getting a lot of attention in the market, and a lot of project I have seen they start migrating towards the GitLab lab in the real world. Okay, so that's what something I'll try to explain you already. And some more thing as we progress, you will understand more and more facility and the capability of the GitLab. Okay. Okay. So rebuilding concept, what they have. Okay, what they have, I will explain you as we progress in this program. I think this will be the good start to start with what actually GitLab is. Okay. So let's start guys with the GitLab. Okay. So if you want to work on the GitLab, you can go for the website. This is called gitlab.com. This is the official website for the GitLab. You will by default land it to about.gitlab.com. Okay. Now, if you want to work on this product or this platform, okay, you have to log in here. Okay, to work on this product. Okay, and for login, you can create a new account. Okay, a new account, and or you can use this way to sign up, GitHub and all the things. Okay, to sign up. Whichever the way you want to log in, you can log in. Let me log in via GitHub. One thing good about if you log in via GitHub is, so all the repository that you have in the GitHub, if you log in via GitHub, they can be accessed from here. Okay, so if, for example, I have already GitHub account, and in my GitHub account, I have lots of repository I was working from last couple of years and months is over here, cutting a lot of code, data also. So automatically these repository can automatically be accessed in this account. So one single account, I can manage the GitHub repository also. There's also one extra benefit you get if you get login from here, or you can get a new account, whatever you feel like. So I already have the GitHub account, so I'm login via GitHub. Okay. So here, this is the bio page you will see. Okay, and guys, when you log in first time, you will see this page. Okay, in this page, we will explore a lot in the future, and even if you go to the menu, so there's a lot of things we will, as we progress, we will explore in the future. Okay, but right now, the main thing that we are looking is called project. Okay, so so okay, what we are looking for. So I'm looking for this setup to be done. Okay, so this word, the way I explained to you, I started actually. So this is called project, right? Any new idea come up, any new requirement come up. Okay, it means a new project come to us, and if the project come to us, we have to develop it. Okay, and guys, again, the main point here would be software development. Okay, so entire software development is called software development life cycle. Okay, so entire software development life cycle SDLC. Okay, we can run on the top of GitLab. When I say life cycle, it means the entire part of CI and CD, continuous integration and the continuous uh, uh, delivery or the deployment. Okay, again, apart from CI/CD, there's some more thing we have, right? We have a SCM also. We have a team collaboration also. Okay, multiple team work together. One team, multiple team members work together. So how well you are can collaborate to each other. Okay, we can see the report also, what is going on. We have to see the live tracking of the code. We can, and there's more thing. So if you guys watch with me in my Git and GitHub training, I discuss a lot of things about how we can collaborate in the GitHub, for example. Something like this and more than this is also we need in the software development lifecycle. So we will see again one more time as we progress in this program. Okay, only getting the code, compiling and building and test. Okay, only doing deployment in the production environment so client can use that is not the only thing. Okay, before and with also we have to how well we can collaborate with the different teams also that can be very sophisticated done by GitLabs. So as we progress, you will see with the practicals all these concepts rather than I keep on explaining you with the just by explaining here theoretically. Okay, so so idea would be what we have to do. Okay, we whenever new project you want to start, project means any new software development lifecycle I want to start in the simple term. For this, you have to start the project. Okay, in the project, we're going to set up the entire CI part and also the CD also in the future. So that time I'll discuss the CD part. Let me start the CI part. Okay, so for this, you have to start the project. The GitLab, this is the option that will come up. Okay, so do you want to start the project to store your code for other features of GitLab that was CI part or CD part? Okay, I say yes. Click on this link. So they start the project. Okay, and now they have multiple options come up. Okay, import the project from Bitbucket or GitHub or from external tool or from template. We will see some of the things in upcoming discussion. But right now, I would like to start the things from very zero. I'm going to create a blank project. Okay, where we will put our own code. We can collaborate in the way I want to do and much more things, especially the pipeline. Okay, so let me create a blank project. Okay, and in this blank project, guys, you guys give the project name. So let's say this is a GitLab training first project. I'm creating here. This page more look like GitHub, but it is not GitHub. Is the you'll see the URL is the GitLab. Okay, so this is your project name. Okay, and that's all. Now here this project right now, this screen behind the scene create a repository for you. Okay, the same repository that you see in the GitHub, similar kind of repository they create for you, means you can manage the code there and plus also managing the versioning and all the concept like branching and merging and all things, you know, can be done here also. But here they will ask you one more thing that is not there in the GitHub. If you know GitHub, okay, it's called deployment target, where this project to be deployed. Okay, means this part. Okay, so where is when we actually this page. Okay, so this page what I explained to you. So after we ask something the code to do, okay, maybe build, maybe test, or maybe some more thing. Okay, where you want to deploy in the Docker, in Kubernetes, in the cloud, in any other area where you want to deploy this code. Okay, for anything. For building also to deploy means if you want to build, you need this part, right? So let's say code is written in the node. So you need hardware, operating system, node, interpreter, or runtime, restore. Then only you can run the code, build the code, test the code. Okay. So because this is the complete platform, one platform for all, they're asking this point to you. So here there's a multiple options we have. If you see, there's a multiple options we have. Almost all the main options that is we use a lot in the real world. Okay, and getting the environment is available here. For example, the Kubernetes. Okay, maybe Kubernetes you can take from your own Kubernetes, EKS from AWS, GKE from Google Kubernetes, or you can use OpenShift platform or this serverless platform for containers like Fargate. Maybe virtual machine from AWS cloud, or maybe lots of more options we have, Lambda, and much more options we have. Okay, so where you get your environment from? Okay, environment means deployment targets. Deployment target means this part, your hardware operating system plus pre setup your Java or Node or Ruby, whichever you need to run or build your code. Okay. In my case, I'm not taking anything. I'm putting optional, basically by default. And if you go for by default, internally they use Dockers by default. So if you don't select anything, so your GitLab internally use the Docker to set up. So when you ask to do something, like say I want to say ask to build or run internally, they will use Docker, but we can change when we want to change. But right now, let me go for by default. Okay. And here, if you want this project to be accessed with the authentication, which is like public, mostly this is what mostly we do in GitHub also, especially in the open source kind of projects. Okay, so it's called anonymous. But if you want this project can be accessed to the user like private, so without login password, nobody can access. Or there's one option called group also. So when I guys talk about group and role management or collaboration concepts, I will explain this concept to you. Let me go by default, or let me go for public also. Okay, to do this. And you want to start this project, initialize this project, I say yes. Okay, so I will go for this option. About other options we have, we might discuss in the future. But this page more look like GitHub. Okay, but this is very powerful options they have. That was one key that makes the GitLab one DevOps platform. And some more thing we're gonna see. So let me create this project over here. Now this project has been created for this project only. There's lots of options we have seen in the last years here. Almost whatever you guys do in the world of CI/CD, in the world of DevOps, or in the world of automation, everything we have: issue tracking, CI/CD, security compliance, monitoring, analytics. Okay, whatever we do in this software development life cycle, all the facilities we have here to be visible. Okay, in our training we'll talk more about CI/CD perspective. Okay, that will go almost cover other things also in automatically. And CI/CD, there's also a pipeline. This will go discuss some that in detail. Okay, but this one project has been created. Okay, and this project and I copy this URL. I now open in a new cognitive window with a login. This can be also accessible, okay, publicly, because I make this project public accessible. So anybody know my URL, they can access this. You guys understand, I believe. Okay, so this is what I have. And in this project, okay, automatically they created one branch called main branch. We can create more branches, the same concept what you know in Git and GitHub training. Okay, and in this project, they created one readme file, the file that you guys know, but we can add more files. Okay, either from this screen, upload directory, create new branches, all the things, the same concept what you have in GitHub. Okay, more file we upload either directly here or maybe from the git command. So all the same command that you know in GitHub, okay, same thing we can do here. Okay, so we can clone this repository locally. Okay, and from the local workstation, we can use the git command to commit, to push, and upload here. Okay, so for management of the code is called SCM, source code management. Okay, would be exactly same, almost exactly same. I can say what you know in Git and just in GitHub. So I don't want to invest this time here as we need. I keep on explaining the basic command again to quickly revise. That is not the very unique thing here that you know already, but this is our this is our own you know some page more look like GitHub. Okay, but interesting thing over here is, okay, per project we can create a pipeline. There is one interesting thing that is again part of our training. Actually, it's main part of training, I can say. We can set up the CI/CD, or here also we have also called setup CI/CD for this project. Okay, so here what I'm going to do, okay, here I'm going to set up the CI/CD. Means in this project, if somebody created a code in Node or Python or something like this, either from here or they upload by this upload push command or get from our workstation of the developer, I want some pipeline to be triggered, or I want CI part to be done. Okay, which part? This entire part what I was talking about. I want somebody have download, environment, build, test, all the things to be done. That can be done by this CI/CD from here or maybe from here. Okay, that's what I want to do. But here, when you see, when I run it, when I set up this, all the operation tasks, setting the Docker, connecting with, get the results, everything can be done automatically. You don't have to worry anything about it. Okay, because again, one DevOps platform it is. Okay, so I will do this pipeline part. Okay, because here we write a pipeline as a code, so I have to first explain the pipeline as a code concept also. Then we will run this setup. So I will do, guys, after the break. We'll go for break of 25 minutes. But before the break, any questions if you have till now, you guys can ask me. So anybody who are there in the MERN training in the full stack. So guys, your actual training name in the summer is full stack development with DevOps. Okay, so anybody who are there in summer, you are not only in the full stack training. The entire course name is full stack development, full stack MERN development over and with the help of DevOps. Okay, and if you don't know DevOps, how we can do the full stack with the DevOps. Okay, so there's one thing, but how we can do a full stack development with the DevOps tool, that's what the part of this training. Okay, so that's what the part of this training. So in this training, I will explain you multiple use cases. If you don't integrate in your development part, maybe full stack or maybe mobile development or anything, then lots of challenges you will face. What are those challenges? So as in this progress in this training, you will see those challenges. Okay, those challenges. So yes, Ratin, you can compare GitLab with developer tools from Azure or AWS also. They also give you hosted solutions like GitLab. For example, in AWS, I think one training also connected. I think that was free or something like this from my side, where I talk about code build, code pipeline. Okay, there's also the one tool from AWS. But how can I compare? There's a lot of big difference. Base concept is same, okay, but there's one big difference in the integration part. Okay, so that is more specific to AWS cloud in simple line. But GitLab is a very much customizable. It is not related to one single cloud. Okay, GitLab can be helping you the way you guys can integrate to any of the platforms. Okay, from Azure to GCP to OpenShift and much more. Okay, so what I'm talking about, I think we understood. Get the platform for the CI/CD in the specifically about the cloud providers like AWS, okay, are specific to the cloud platform. They are using their cloud services, their specific cloud services. Okay, for storing the using S3, AWS cloud. They are for deployment. They're using their Kubernetes Kubernetes. They have that is called what are the ACK cluster. They're using Kubernetes, AWS Kubernetes cluster. They're using their specific tools and the services. But GitLab is a open platform. Open means whichever platform you want to integrate due to your specific use cases, you can do it. This is one reason. Otherwise, because you guys know already, if you guys know already the cloud respective CI/CD tools, there's a hosted managed by the cloud guys. And after running GitLab also, you guys can compare very quickly, okay, what they were providing you and what you are having. Okay. Can we replace Jenkins with GitLab? No, I'm not actually, my motto here is not to just try to degrade the value of Jenkins and give the GitLab in the higher position here. I love both the tools, GitLab and Jenkins. Depend upon the requirement. Okay, almost in all the companies, they already have deployed Jenkins in the working, right? And everything is being integrated, everything working fine, has been tested, right? So in that case, they have using Jenkins, and mostly Jenkins give you very internal controls because Jenkins software also open source also. And we install Jenkins in our setup, so they give you more controls. Okay, they have tons of plugins because it's very mature product, right? So Jenkins has their own place in the market, that I'm trying to tell you. GitLab is very new compared to Jenkins, and here they are giving their own offerings. Okay, here they make the things pretty simple. Okay, for the new startups, for the new projects. Okay, anybody who don't want to set up the entire new setup of CI/CD in their organization. Okay, in those cases, and those use cases. Okay, and these are, I think, some good use cases. Having the GitLab makes much sense. Okay, but in a corporate world, if you already have the DevOps team that is already been so much mature, okay, and already Jenkins kind of setup, maybe Jenkins or Circle CI, whatever the tool would be, already been set up. There's no good reason to migrate to this tool. So very rare case you will see, but newer startup, you don't want to invest on the management part of it or operation part of it. Okay, then this GitLab is a great choice to have. Okay, so So I think this difference you might get to. Otherwise, what is artifact? Papu, nothing. Software is also known as artifact. So when you have the code, if you compile the code as a Java, this become a package. A package is one who will or we run always. Okay. And that package is also known as artifact. So either you can use the word package or the artifact is this a same thing. Okay. Is there any difference in scalability and the availability difference? Yes, we do have Asutosh. This is the one of the example I'm going to show you today. Okay. And there's one concept called executors here. They will automatically scale the executor. So auto scaling is very powerful. Okay. In Jenkins, we have to manage the resources. If more executors we need in the Jenkins, we have to manage the resources, or IT team has to manage the resources to more and more resources, to add more and more resources, moreover executors. Here it is like an auto scaling kind of thing. You don't have to manage the auto scaling part. So we have a practical on this and discuss also on this. I just want to hold for a minute, but yeah, you will get this answer maybe in today's class or maybe in the next class. Okay. Yes, Prakash, you can use GitLab for everything. You don't need GitHub. Okay. For management of your GitHub, normally we use for SCM mostly. Okay. Other things they have options, but mostly we use for software source code. But GitLab can do all the software management features here, the repositories they have. So all the things what you normally do in the repository or the source code management we can do, and much more things we can do here. So typically everything in the management purpose of CI/CD, you can use GitLab. But what's all CI/CD can do for you as we progress in this program, you guys come to know, that will be the maybe right time. You guys can compare. Okay, now this part can be done by GitLab. What else we need? And that will be the right time to discuss further about, okay, this part now who can handle. Okay, so because setting up the CI/CD is one thing. Okay, after this also we might have to do some more thing. What are those? We will definitely discuss if you have these points in your mind. Okay. Yes, so we can add multiple pipelines, also connect multiple pipelines is what I'll show you how. Can we integrate GitLab with our hybrid on hybrid cloud? Answer yes, you can integrate. Okay, I might give some idea on it, how we can integrate with the hybrid cloud if we need. Yes, GitLab also work for the monitoring part of this here. They have the monitoring part here in your, this is more respect to your CI/CD. You can see all the monitoring from tracking to metrics. We'll also talk about this monitoring part, analytics part, and some more things as we progress. Okay. How to deploy on private ACO instance? I will give or might give some ideas. Okay, how to deploy from the GitLab to instances like EC2 instances. Okay, or maybe Kubernetes also here. This training is more about GitLab. Okay, so I won't tell you all the integrations of respect tool, but I give some of the examples with a practical example. By looking at those examples, you guys can understand the entire concept. Then whichever you want to add or integrate further, okay, or other platform, you guys can do it. Okay, it's similar to Azure DevOps. Again, guys, every cloud platform has their own DevOps, stack. Okay, but they are more respect to their own cloud. That's what somebody was asking here. AWS also have, Azure also have. Okay, so they are very specific on their offering or their services. Okay, but maybe in this project or maybe in our project, we don't want to use all the service from Azure. Maybe we want to use all the offering from AWS services. Okay, so this is a one tool that give you a way to configure, okay, wherever you want to configure, whichever things you want to integrate. Okay, so they give you lots of options to integrate here and there, depend upon your requirement, right? So again, if you know about AWS or Azure or some other cloud DevOps services tech, after you see the GitLab and some more facility, you guys can compare very easily. Maybe this might not be the right time to give you give you the those comparison, but yeah, as you progress, you will see a very quick difference in some time. Okay, so MERN training companies, Avinash will tell you soon, right? We'll tell you soon. This training is going on, but we'll update you soon when this training will be complete. Okay. So that's all, guys. Let's go for a quick break. And I think if you can see how it works, and slowly you guys will automatically compare it, right? Because not everybody work in AWS DevOps or Azure DevOps or maybe in Jenkins. So I'm just trying to restrict myself to talk more respect to the remaining platform. I'm trying to speak generalize so that everybody can sing in this training with me. Okay. But those who know respective tools, as we do a more practicals, you can automatically compare. Also, I might also keep on touching some points there. Okay, this is not there in Jenkins. This is not there in AWS DevOps. This is not there in Azure DevOps. So that I can keep on giving you the information that point in time. Okay. So let's go, guys, for John, I will talk about the GitLab account offering. Is it free or can we host locally? Answer yes. Cloud based, this is what the cloud base I'm using here, GitLab. I'll talk a little bit maybe today. If I get a time after writing the pipeline or maybe tomorrow. Okay, about the multiple offering or subscriptions they have. Okay. So that's one thing. So right now it's free. What I create an account is free. For some limit, what are those limits also I will talk about. Okay. So guys, let's go for a quick break of around 45, sorry, not 45, 25 minutes. Okay. So we will continue after 25 minutes. Bye. Take care. See you. So guys, welcome back and let's continue. So what I'm going to show you here, how we can create a pipeline. Okay, what is pipeline? I explained you already. So whatever things you want to do as automations, as your steps, or I can say stages. Okay, so it will be something like this. We have a code in SCM system. Okay, SM system. Let's say, let me put the code here. So my SCM is my source control or software control management system, or source control management system. In my case is this one, GitLab only. And let me add my code. So here, okay, in this page, I have only one file called readme. Okay, but I'm going to add more file, a new file over here. Okay, and let's say my plan is to create a file with a name called hello dot maybe let's say scripting file, ss file. Okay, I'm going to write some shell scripting here as a code. And normally we start the shell scripting in this way, bin-was. It is not compulsory, but we can start in this way. And let me write a command called date command. Let me write a command called echo welcome to the next one is a basic Linux commands, or same Linux command you can put in the file, then it becomes a scripting. Okay. So one file I created. Unless this code has been created by my developer. Okay, and after they create the code, this code they uploaded here. Or we can directly create the code here. That's what I'm doing right now. Okay, in this file. So this file has been created, and let me save this file. Okay, let's save this file. So this one new file has been saved in my current repository, and the name of my repository is this one. This one I created as a project name. So what a project name you created, that is also work like your repository. Okay, and I say this file we have with us. Now till here, GitLab is it's keep on monitoring this project. Okay, and then looking for the automation. Who is looking for the automation? GitLab. And they keep on tracking or keep on checking. Okay, whenever you ask GitLab to do the automation, they will do it. But for the automation, one thing we need, what we want in the automation. Okay, so in the automation, I want whatever code I put here in this SM tool. In my case, I put the code hello.sh. So whatever code I put here in this system called hello.sh, I want GitLab will take this code. Okay, and for me, they will run it. That's what I want. They will run it. Okay, and there is no good reason to build this code. Normally, this is a scripting code, and a scripting code mostly we always run. Okay, there's no good reason to build. Okay, so I want this code to be run. Okay, very simple code. So for this, let's say this is the only requirement I have. So I want, as my developer do anything in the code, maybe that's for code change. So as the code change happen, okay, and this code change uploaded in the SM system, okay, my GitLab automatically detected this code has been changed. Okay, and at the code change, they automatically run the code. So for this, we have to create one pipeline. Okay, create a pipeline. Now, it's your choice. In the pipeline, you only want to run the code, or in the pipeline, you want your code to be first build, then run, then test, and much more thing. It depends how many stages you want to perform. This called stages. Okay, so you want to only run the code, or much more things. That's why I explained in my diagram also, you want to perform. Okay, so how many stages you want to perform? Stage 1, stage 2, stage 3. All the stages will work together, maybe in parallel or one by one. I'll show you how to make it parallel or sequence we'll discuss in some time, but this is also a pipeline. Okay. So GitLab doesn't know anything about your pipeline, means what you perform and what you want to do. Okay. How many stages you want to do or what you want to do in this pipeline. Okay. So for this, you have to create a pipeline. Because right now I don't have a pipeline, so GitLab is not doing any automation here. So if you change and you keep on changing the code, let me again open this code. Okay, after open, just go and let me edit this code. Even though guys they have their own IDE, or maybe we can also edit without the IDE also. Okay, edit this file and let me click on edit. So maybe if you just do one more change, let's say you go more changes. Okay, I do a lot of changes here and save. Let's go commit here. So we know we have done these changes. Okay, but GitLab is not tracking any changes here. Okay, is not tracking any changes here. Why? Because right now we haven't created any of the pipeline. Okay, that's what they're not tracking any changes here. But if you want any change I do in this file, okay, GitLab will track. Okay, and after track, they will do those changes. Okay, for this, we have to create a pipeline. Okay, we have to create a pipeline. So what happened as we change something in the code? Okay, GitLab automatic detected. And when they detected, they automatically run the pipeline. But what pipeline will do, what I will explain to you, they will do all the CI part for you or CI/CD part for you. And CI/CD part, we have to write the stages here. Okay, to demonstrate this entire practical, let me focus only in the pipeline right now. I'm trying to set the context here. Okay, but let's say, let me delete this file for a while. Okay, let me delete this file. Okay, let's focus on the pipeline part rather than we again, go for this process. Okay, so my main point here is, or my intention here is that GitLab will only do a CI/CD part or the automation part. Okay, if you have a pipeline created. Idea is very simple because they don't know what you want to perform. They don't know your stages. Okay, so you have to create your stages in the pipeline, and accordingly GitLab will perform those stages for you. Okay, in the same sequence the way you write. Okay, so it means we have to create a pipeline. That's what the point is. Okay, and to create the pipeline, what you have to do, maybe one of the very typical pipeline would be, I want whenever pipeline run. Okay, whenever pipeline run, we want something to be done. Let's say there's something to be built. I want build to be done. After build done completely, then I want my pipeline will test something. Then after test, I will do something. Before building test, I will do something. Before build also, I want to test something. Okay, depend upon your requirement of the project, what you want to do. But let me take only those two parts. So in the pipeline, I can say I want to do two stages. One stage is called build stage, and I want the second stage to be called test stage. Okay, so when this pipeline run, I want these two stages to be done. Okay, and whenever you want, guys, GitLab will do something for you. Okay, GitLab will run the pipeline for you. Okay, you can think pipeline is one kind of program just to make things understandable. It's kind of program. Okay, so in the program we will tell that I have two stages, build or stage and much and more or less maybe. So when you want to run this program, you want to run the program, that point in time for the GitLab perspective, that is called job. Okay, so whenever you create a pipeline, inside the pipeline, you have to tell that this is the job you have, this is a job you have, and you want this job to be run. Okay, so you can think in this way. We will create one program that is called pipeline. Okay, let me write here pipeline. And inside the pipeline, we'll tell this is one of the job I have. Okay, I want to perform. And in this job, I have multiple stages. I have the stage 1, I have the stage 2, I have the stage 3. Okay, stage 3. This stage I want to build the code. This stage I want to run the code. This stage I want to test the code. But in one pipeline, we can add more jobs. Okay, job number 2 that has other stages. So why we need more jobs? That's a different point. We'll see maybe today. But let me focus on this part only. Okay. So when you create a pipeline, you create inside the pipeline, you create a job. And technically, for GitLab perspective, they have to run one job. And inside the job, you write what you want to do in the stages. So let me guys show you how we can do it. Okay. And second thing guys here is, if you want to tell something to your GitLab, you look at a pipeline, and to tell anything to program, GitLab is also program. Okay. So to tell GitLab that I want to do something, so we have to write a code. So here we have to write pipeline as a code. So you have to write a code over here. Okay. And code we have to use. With this code, we will tell the instruction to GitLab. Okay, that this is my pipeline, these are the steps I want to perform. Okay, and any instruction if you want to give to GitLab, you have to use certain specific declarative language, and one of the language that I would like to use here is called YAML. So code that we have to create here is called pipeline as a code is a concept, means with the help of code, I'm going to tell the GitLab this is my pipeline. Okay, pipeline means this is my steps I want to perform. And the code we have to write in a language called YAML. Okay, so let me start, guys. When I create, you guys get more insight about it. So in your current project, okay, and the project in your current repository, okay, in the same current repository, you have to create a pipeline. Okay, or you create a pipeline as a code, and because it is code, you put the code in some of the file. So you can create one file. Okay. But for the pipeline, there is one specific file that is a prefix name. Okay. For example, if you see the template type, okay, they give a lot of examples here. But if you want to create a GitLab pipeline, this is one file we have. Okay. This is a special file name. Okay. So those who know about Docker, this is specified in Docker. Those who know Git, this is a special meaning of the Git ignore in the Git commands. Similarly, okay, in the GitLab, this file has a specific meaning. So if you create a file with this name, okay, then this file has a special meaning. Okay, what this file meaning is? It means this file is been keep on tracking by GitLab. Okay, and this is a file where we're going to write a pipeline. Okay, that's how, and this is a location, guys, where we write the pipeline as a code. Okay, so there's a file name we would like to use here, and this one thing. So whenever, guys, you want to get a pipeline, you can change this file name also if you want. There's some way, but this is the standard file name. So any pipeline you want to create in the GitLab repository, you have to give a file name, this one. Okay, this is the file name you have to give. Now, how to get a pipeline? For creating the pipeline, okay, in the pipeline you have to create a job. Okay, and for creating the job, we have to give a job a name. And here you can give any job name. So maybe let me write the name of the code, my first job. That's all. So very straightforward. If you want to give a job a name, okay, this is the name you can give. Maybe any number of strings you can write. You can give a space and just also, okay, there's a job name. And everything your job name has been given properly, then you can use colon and tell what you have in the jobs. Okay, what you have in jobs. Here you can give inside the job, you can give the stages of the job. But before I go for stages, let me tell you a very small thing, just to give you a very quick information here to creating the pipeline. So inside the job, okay, you can write a script. Okay, even though guys there is lot of automatic live options come up. There's not coming here because here I give the name somewhere here. Now this works properly. 1 minute. 1 minute. Actually, the automatically option is gonna come up. 1 minute, please. Let me go back. Okay, so then again create a new file. And my plan is to create a um, pipeline file. There's a bit of a file we have. I give the name, and here I can give my job name, my first job, whatever job you want to write. And after job name completed, to differentiate and tell the job is completed, you can use colon that this job has been now. This is the name of the job. Now in the job, what you want to perform? Okay, let's say I want to perform a script. Okay, I want to create a script. Okay, means I want to run some command. Script means if you want to run some kind of script like a cell script or cell command or an Excel command. Okay, you can write here. Okay, so let's say I want to run a script. Let's say echo welcome to the next word. Or I have to run one more script, date. Or let's say one more script, maybe echo by. So typically, this is the job name. Okay, and the job, when the job run, these are the scripts I want to be performed. I'm just showing you very quickly the look and feel here. Then we'll go more deep. We'll add multiple stages, multiple jobs. That makes more sense the way I'm explaining to you. But I'm just giving very quick information. But by chance, the way I'm writing the code here, this language is called YML language. YML or YAML language. Okay, so those who by chance doesn't know about YML language, let me very quickly explain to you. Okay, what the YML language is and how it look like. Okay, so the idea will be pretty simple. Those who don't know about YML language. So nowadays, guys, very standard in the market. If there's a one program running, okay, one program running, and from your system and from your side, if you want to give some instruction to this program, that based on my instruction, you perform something. Okay, let's say your instruction would be, I want do one thing. I'm giving one thing that this program, I want this program uses some kind of memory. I want my memory to fix to 10 MB. Don't give more than 10 MB memory. Or I want this program is running, and I want this program is going to shut down or reboot or restart, okay, or maybe kill after 2 hours. I'm taking some random examples here, numbers here. Okay, so if one program is running and they are asking you maybe as a user or the admin of this program, and they say you guys can control me or my facilities, okay, by just giving some information or by declaring some information what you want to and how you want to use. So you can give them some data to me and information to me. Accordingly, I will reconfigure myself. Okay, a point here is, okay, if I'm giving, let's say 10 here, so how they know this 10 is 1 minute, sorry. How they know this 10 MB is RAM or hard disk? What they mean by this 2 hours? This 2 hours is to reboot the system, or after 2 hours send email. How they come to know? Okay, for this every value you have to give some name. Okay, so maybe here I can say my storage size is equals to 10 MB, or that interval or the time interval when you do something would be 2 hours. Okay. So this program, the whoever created this program, right, whatever tool, whatever the program is doing, that is not important. Maybe cloud program or automation program, or maybe configuration management program or CI/CD program, right? It would be any kind of program. The creator of this program, okay, they created this kind of keyword initially. Okay, inside this, they inside here, they write something like this: anybody in the future send anything over storage size, anything over storage size. It means they are asking me to set my storage size or my memory size or memory limit. Okay, so this program has been created by somebody. Okay, they understand this keyword, this is called key, but they don't know what my user or admin looking for. Now, according to this example, now this program, let's say, is running by default settings. Now, any user who want to use this program, let's say we are the one who want to use this program, and I want to set something, whatever the supported actually, what a key this supported. Okay. For this, what can I do? I can get one file. Inside this file, I can say, I want to do some changes on you. And my change would be, I'm trying to change your storage size limit. I'm not looking for whatever default settings you have. Let me set for 10 MB. And some more key we write. And give this document to this guy. And as I provide this document to this guy, okay, program take this document, according to this document, whatever I write in this document, they reset it. And depend how they want to use that will be their choice. Okay, so in this particular example, okay, this is a very normal nowadays, very standard process. Almost every platform you will see, maybe in the cloud to any DevOps platform. Okay, where the user and the admin of the tool, they will do their changes and they will change some setting on this main platform by providing this document. But in this document, we have to follow some standard format or standard language to write these instructions. And that format mostly we use called YAML, yet another or yet INT markup language. Okay, it's kind of markup language. Okay, so those who know about web development or web technology, there we use a different format called JSON a lot. Okay, but the platform like cloud, platform like like a DevOps platform where we have more about admin management task or configuration management task. This is a very common standard format we use in the market called YAML. Okay, but YAML has their own syntax, and syntax will be something like this. Okay, so you're going to give the storage size. So we can write the storage size or limit equals to 10 MB. Instead, we write in this way equals to, we have to write colon. So you have to write a colon separated. So before the colon, this is called key, and after the column, this is the value. We can say, for example, my interval time or my reboot time, let's say 2 hours. 2 hours. Okay, and because 2 hours look like more like a string, so we can write in the double quotes. 10 maybe look like maybe not a string, we can write without double quotes like integer or the number. But this is how, guys, we write YAML syntax. So the key and value pair. Okay, key value pair. So this is what known as YAML syntax. Okay, or maybe, for example, let's say I'm looking for some name and somebody give the name called Vimal. But sometimes I'm looking for some name and they want to give a lot of name. This is called list of name. So Vimal is one name, Pop is other name, Eric is other name. So whenever, guys, any key that's called variable have a lot of names or a lot of values, it's like a list. Okay, so we don't write list in this way in YAML. Instead, we give every item a hyphen. After Vimal, hyphen, before Pop, hyphen, and after Eric, hyphen. Okay, so name is a key, and these are the value or the item of this key. So every hyphen means this is the first item, second item, third item of the value key name or the variable name for Vimal, and these are the items we have. Okay, so this is also one of the syntax that we have in the YAML. One more thing, guys, because Vimal, Pop, and Eric is a different value of or item of the name. So every should be in the same indent. If you give 2 space here, it will give 2 space here. So this space is called indent or indentation. It should be equal. If you give more or less space to anybody, it will fail. So typically in the YML, any block of code you have or block of information you have or list of information you have, you give the same space, otherwise they will fail. Okay, so those who know by chance Python language, in the Python, you write a block of code in the with equal indentation or equal space. Same thing you can type here. Now to your choice, you give 2 space, 4 space, that will be your choice, right? But you have to give equal. So guys, this is a quick information about YML. Okay, and YML is not only for GitLab. A lot of platform, if you go to Kubernetes, if you go to other platform, same YML you'll see here. Only difference would be they have the own specific keyword. So this keyword is supported by my program. Some keywords support in Ansible, some keywords support in Kubernetes, some other keywords support in GitLab. So what a keyword their program support internally, that keyword we have to use, because with the help of this keyword, we are giving the instruction to this guys, or we're declaring something. And that is a reason it is also known as declarative language. Okay. So here we have to create a pipeline in the GitLab with the help of YML as a language. Normal extension of file is normally give YML. The name of the program is called YAML. And here we have to give the instruction to this program in a way so that they can understand my instruction. So we are the user, or we are the DevOps engineer, or we are the admin. Okay. And if you want to give instructions to the GitLab, how can you give? To give the instruction to the GitLab, okay, from our side, we are the DevOps engineers. Okay, we have to use YML language. But here, what instruction I want to perform? Here, I want to give an instruction to the GitLab. The GitLab, okay, whenever you want to run the pipeline, so these are the instructions I have. Perform it. Okay, and GitLab say I can understand your instruction, but you have to use a keyword that I understand. Okay, so for example, if you want to run any Linux command or want to run any shell scripting or any scripting that can run in the Linux prompt, okay, you have to use script keyword. Okay, and because script is now is one key and value script skill would be what commands, and because we have multiple commands, okay, so the list of commands we have, so we use hyphen to tell the list of the command list. Okay, this is how we write here. Okay, so in my one job, okay, I might have to do multiple things, but one of the things I'm going to do is script. In a script, I want to run multiple commands. This is a command I write here. Okay, so this example, guys, won't give you a very solid view of the pipeline. The way I explained to you, build test. We'll add it in some minute. Okay, but let me run this pipeline, okay, to just see how it works, how it runs, and all other concepts, right? Or maybe something might be fail here. I might focus on keyword. Let's see. Okay, now I save this pipeline in this special file. Okay, now what happened? This is a normal text file or normal coding file. But now if I save this file, commit this file, change, save. Okay, let's see at the automate. There's some kind of something is this arrow here. This running pipeline running, right? Pipeline running. So it means in this project, if you talk about, okay, I might have multiple files. This file, let me add other files also. I show you already. Okay, any file is like a normal file. You can add the code, text, document, right? But this file has a special meaning. Okay, and GitLab say if you do some changes in this file, whenever you change, okay, it will help me to trigger the pipeline. It will help me to restart the pipeline automatically. Okay, pipeline means I will do something for you automatically. Okay, and right now we're going to change something or create something here. For example, let me edit some more thing here. But let me add one more command here. Let's say echo new data. Okay, because you're changing something in the pipeline. Okay, so when you commit, means you save. Okay, I automatically come to know that you committed or you changed something. I automatically first check the syntax for this code. The syntax is valid, there's no issue, and automatically start the pipeline here. This pipeline starts. Even if you click here, you will land it to the pipeline page. Right now, pipeline running. You can cancel if you want. The pipeline running. This is the pipeline is running right now. Okay, but in this pipeline, guys, we have created one job. You can see in the top, there's one job, and the job name that I given is for my first job. Same name gonna come up here. Okay, this tick means there's no syntax error in this pipeline, and all the commands they run successfully. Even if you click on the jobs, okay, so this job is the one I given the name, and this job is running, I believe, or maybe completed, or it takes around this much second to run. Okay, that's what they tell you. But let me go back to my pipeline again. Okay, if I take this pipeline is created. If there's option, guys, here, you have to rerun this pipeline again. Okay, so maybe due to some reason I want to rerun or it's failed. So I can click this button, they will rerun this pipeline. But before this, let me go back to my again to my code, or maybe I can click on the editor here on the left side. Okay, if I click on the editor, I will land it again to the pipeline automatically in this file. Let me add more thing here. Okay, echo new more data. Now, what I'm trying to show you here is this is the pipeline name you have given. Not the pipeline name, I can say the job name. In one pipeline, we have multiple jobs. Why we need more jobs? I'll tell you. Okay, but in this job, you instructed you want to run the script. This is called the script you have given or the commands you have given. Okay, now when I save, or because I change something here, when I save, okay, this pipeline automatically run. Okay, this is called auto trigger. The automatic run. This is one thing. But interesting thing is that I want to show you here is the interesting thing is whenever your pipeline run, okay, who run this pipeline? Okay, who create this pipeline first of all? This pipeline is created by us. We have to create it. Why? Because we know what we're looking for, right? How GitLab know what we're looking for. So we have to create this pipeline. But when this pipeline run, either you run pipeline manually by clicking on this button, either this pipeline run automatically. This is called trigger pipeline automatically run. Where do you save it? Okay. So at this time, this pipeline run by GitLab. Okay, for running any pipeline, you need the environment, right? You need the environment. Okay, environment means your operating system. So how and which environment GitLab is using behind the scene? So from where they are getting the physical hardware, which operating system they're using, on the top operating system, what kind of program software here they're using. Shell, for example, shell means the Linux bash program they're using to running the command. From where they're getting this environment. Okay, so GitLab, guys, by default getting the environment for deploying anything or to running any code, maybe for build or test, they're getting this environment from the Docker by default. Okay, from the Docker. Anybody who know about the Docker, in the Docker, if you want to launch any operating system or the environment, okay, it will launch by the Docker with the help of Docker images. Docker images. Okay, this is very basic, right? So it means GitLab is using some image of the Docker, and from this image they are launching this particular environment or the operating system. And you guys also know in the Docker this environment is known as container, so they launch this container for us. Okay, and because they're using Docker, and you guys know the one power of Docker. Okay, if you have the image, okay, if you have the image, from the image launching this container, what always will take more than or less than, not more than, less than 1 second. So very quickly this environment launch. Okay, and on the top of this environment, whatever commands you want to run, or whatever script you want to run, it would very quickly run. So in my case, my GitLab automatically copy the script over here. With a script, this script, and run it for us. Okay, run it for us. So that will be done by GitLab automatically. So let me show you very quickly. Now, as soon as I save this, commit, automatically this pipeline run. If you click on the view pipeline, you see one job is started. If you click on the job, there's one job is started. If you click on the running of the status, you can see live status of what is happening behind the scene. Okay, here guys, everything is job succeed. What a job you write is succeed. It takes around 14 seconds to finish this job. And guys, this time is very important. Okay, one reason is it will help you to optimize your project, to enhance. What can I do? I can decrease the time of running. Second thing is GitLab is charging you guys the normal pricing model in the GitLab, okay, is for the time. So they give you the subscription, and one of the part in the subscription they give you time. For example, for thousands hours or for 100 hours per month is free. For example, I'm just giving a random number. Okay, and if you want to run your project, okay, inside the GitLab environment, more than thousands hours, they will charge you that much and that much, right? So this is how they work. I will talk about the pricing model in my next class, but this is what they have normally, right? So this job is just finished right now, 14 seconds ago. But if you go up, okay, what you see, GitLab has guys created this environment for us. So when we ask, are this job to be run? Okay, and this job is automated triggered. Okay, why? Because I changed something in this file. What a file I show you already. I changed something in this file. Okay, if I say something in the file, this job automatically triggered. And in this file, because I give the job this name, what name you give, same name of job gonna come up here. Okay, in my account, this is my account name. Okay, account name, or maybe we have working on the collaboration of with other team. They also name gonna come up who run this job. Okay, to running this job, it takes a total of 14 seconds to complete this job. But in this job, okay, GitLab is going to run a runner from the GitLab managers. Okay, what I mean by this. So the normal architecture guys of the GitLab is something like this. Okay, whenever any job come to GitLab to run, so this job is managed by one centralized program internally in your account. It is called GitLab Manager. Okay, so whenever any job come and you want job to be run or execute, GitLab Manager is the one who going to manage this job. Okay, but this is duty of the manager is to run this job. They will launch one program here. Okay, and name of the program is called GitLab Executor, or also known as GitLab Runner. Okay, so when a new job come up, GitLab Manager will spawn and start one runner for you and hand it over this job to GitLab Runner and say, now this is your duty to run this job. And for this job, what a deployment environment you need. In this case, by default is Docker. We can change also. And in Docker, whichever the image they need, let's say what image they use behind the scene for Docker image, use it. Okay. And in this job, it is defined what kind of things they want to do, build or test or script. Okay. So on the top of this image, launch your OS, the container, and run the script and give you the results. Okay. So you can think it is something like a master slave model. So this manager is like a master and it is like a slave. Okay. But interesting thing is Okay, this slave automatic launch on demand. Okay, you don't have to need any managers, and the slave manager also launch. You see guys here, manager also launch automatically whenever the new job come up. Okay, and automatically your runner also launch for us. Okay, behind the scene as the demand come up. Okay, and there's some example gonna come up in the future where you see you need more runners. So as per the requirement of the project, if you need more runner, one runner, two runner, hundreds and thousands runner, they will launch for you. Okay, it means this concept is called scalability. More demand we have, more runner we need, more runner is sometimes also known as executors. So if you need more executors, okay, they will launch for you 1, 2, 3, and 4 and 5. It's called scaling. So you don't have to worry about the scaling. They will do auto scaling, means more, launch more and more computer, more and more runner who are the one who taking care about the deployment part, and the remaining part of your code automatically by the GitLab here. Okay, and again, you don't have to worry about the resources from where they're going to take the RAM and CPU, because this is the GitLab. Okay, and right now you're using GitLab in the cloud-based solution here. We have some way to get the GitLab in our local on-premises also, but right now we're using GitLab in the GitLab, the on hosted solution is for GitLab Cloud. So you don't have to worry about the resources they will give to you as your demand increase. So you don't have to worry about your physical resources. You don't have to contact your IT teams. They will give you, because they are charging you per time. More resource you use, more time it consume, more they charge, something like this. Okay. Otherwise, we'll look more about it as we progress in this program. We will discuss more about this architecture. Okay. Now, I told you guys behind the scene they're going to use some image. By default, image they use is this OS image. So this is the image they're using, and they downloading from the Docker Hub. So if you guys know about Docker, you might know about Docker Hub also. So from this portal, they are downloading this image, and in our case, they are using the image called Ruby. Okay, but we can change the image name also if you want. They are using this particular image over here. But in some example, we need to change the images. Why, I'll tell you today only, and how to change and how to use our own images also. That also I will explain in somewhere. Okay, this is what they are doing here. Okay, now in the Git Hub, the good thing is they're telling guys the times here. Okay, this part taking 0 second, this part taking 1 second, this part taking 0 second. So to improve your performance of your project, maybe let's say build or testing, we can think about where they're taking more time to focus about the posting. Also, you can check also the total time where they consume more or less according to your plan. Okay. Now, what they do, they're getting the source code from your Git repository. That's what I talk about. Okay. So by default, they're getting the code from our own current Git repository, which is hosted here. Okay. They're taking from here the same thing they are getting. Okay. And then they are using this image. From this image, they launch a container. This is what the container they launch. Okay. And in this container is this operating system. Okay. In this operating system, they put your entire script and run it. See here, the entire script. Welcome to read command by and new data, this data complete. And after your entire script run, your job succeeded. So one pipeline run successfully over here. Okay. That is how it works. Okay, so let me go back to our pipeline. So this is what the guys they show you here. This pipeline ran 4 times, and all the top 5 times by chance they pass. That's the nice thing we have here. Okay, let me do some more thing here. Let's do something that makes my pipeline maybe fail. Okay, before this, let's do other things. Okay, let's say I want to get a stages the way I explained to you. Okay. So my plan is in this one single pipeline, how to create a pipeline as a code is called pipeline as a code or as code. Okay. I want to create one job. Okay, one job. In this job, I want to create two stages, stage 1, stage 2. Okay, depending on the requirement, you can give any stage name. Okay, or maybe let me give the stage called this called build stage, and let's say this called test stage. So 2 stages I want to get in one job. That's what my plan is. Okay, so how can we do this? Again, I go to my editors in CI/CD. Okay, and this is what the file we have. Let me copy this code in the other file. Okay, so here I would like to give my project name. Let's say web app development. Okay, job 1 is give a it is just a what I say job name. Now in the top also you can see that in the real time they keep on checking the syntax of this file is not right. It's not well formatted because it's not a pure YAML. Let me put comma, colon, enter. And now here, what you want to do, you want to create 2 stages. Okay, and to create the 2 stages, okay, what you can do to create 2 stages. Okay, first you have to create 2 jobs actually. So every stage that will be part of a job. So this is the web app development job 2. Why I'm doing this, let me tell you in a minute. Okay, so there's 2 jobs I'm creating, and I said this job I created for build, this job I created for test. Why I create 2 jobs, I'll tell you, because in one job also we have to write multiple steps. Okay, now in this job what I want, let me run a script, for example. Same thing. Okay, in this case I'm going to run the command called echo my build job, for example. Here in this job I will create a script again, colon echo my test job. So I'll show you guys in a minute about stages, but let me do this demo first. So what I'm trying to show you here is in one pipeline. In one pipeline, okay, I created 2 jobs, job number 1 and job number 2. Okay, and the respective job, I created one script. And this is the script or the Linux command line. How we know? Because of the script keyword. Okay, otherwise we have more keyword, we'll see as we progress. Okay. Now this code is syntax is right, or we click on validate. We'll talk about validate in some time, but this code is right. But visual is a good way to check. Okay, and the visual, if you see, they will tell you they have 2 jobs. Okay, so every job they get different buttons and different kind of this box. Okay, 2 jobs we have. Now, let me save this, and as I save, automatically your pipeline starts here. This pipeline is started. Okay, and in this pipeline, if you click on the view pipeline, now this time you will see the 2 jobs is running. So here, this 2 jobs is running right now. Okay, running right now. And if you click in this job is successful actually very quickly, but they was running. So here, this is the build job run successfully. Or if you go to my pipelines, if you go to this pipeline is passed already. In this pipeline, we have 2 jobs. Let me click in this pipeline. Okay, in the pipeline had 2 jobs. Both the job run successfully. If you click here, this job also run. Okay, test job and all the jobs will run. Okay, so so one thing what I want to show here is in one single one single pipeline, you can create two jobs. The one thing I want to show you here is, second thing is, if you're running two jobs, both the jobs run in sequence. Sorry, not sequence, in the parallel. Okay, both the jobs run in the parallel. So this and this both run in the parallel. If you see the time also somewhere, okay, you will see both the jobs run parallel, even though very quickly. Let me go to editor. In the editor, if you let me write a one command called sleep command for 30 seconds. I'm pausing this job for 30 seconds. Sleep is a one Linux command. And when I sleep, it will hold here for 30 seconds. Then this line will run and then the job complete. So I'm pausing this job for 30 seconds. Okay. And the view pipeline, what I'm trying to tell you here is, in a minute, there's some things you have to manage here. So both the jobs is running. See here, exactly they are running. If you click the job is started already. They're getting the images and try to launch something. Okay, at the same time, go back. And if you see the second job, they're also running here. See, okay, both the jobs are running on the same time. If you click second one, this is also running. Okay, both the jobs are running right now. So my point here is, when you create a, now this is succeed and that's also been succeed. If you go and back and see. Okay, your 30 seconds I think has been completed. So this also been completed. But point here is, in one pipeline, there's a lot of requirement come up when you have to create jobs. So if you get two jobs and more jobs, they will run in parallel. Sometimes running the job in parallel makes much sense. Okay, but in some use cases, it won't make any good sense. For example, let me change something in the code. Let's say this job is going to create one file with the content, let's say Vimal. Okay, and I'm going to create a file called hello.txt. This is a Linux command. Okay, so here I'm going to create a content in this file. Okay, this job is creating. Okay, and this job duty is to test the content is there in this file or not. Okay, so this job is getting some content from somewhere, creating this file. So it is more look like a build. They're building something. And this job duty is that whatever build we want to check. Okay, whatever building is right or not. Let's go testing. So let's say this job is more about testing, and we have a grep command, for example, in Linux to check does Vimal content is there in this file. So grep is a command in Linux to check this. Okay, those who by chance doesn't know this command, let me show you very quickly. In my command line git bash I have, that give me Windows kind of Linux kind of environment here. So if you run this command echo Vimal, okay, and let me put into this file txt, this data is stored in this file, but to check this Vimal is there or not. So we can write Vimal and see this file is there. But if I try to search in any other data, they won't give anything because the data is not there. So grep is a command to do this. But the important thing what I want to show you here is, whenever you run the grep command and they're not able to search it, they're not able to get the content what you're looking for, internally in the background, grep command throw the error or throw the error that I'm not successful. So here they throw the error that I'm not successful. Here they throw the error that I am successful. And normally in the Linux command prompt, okay, any command that you run and they don't run successfully, then internally they send the message, this exit code that you can retrieve from this keyword. This keyword. So this is dollar means variable, as question mark is special variable. So any command that you run in a command line in Linux prompt especially, okay, if last command runs successfully, you can use this command to check the exit code. 0 means this command is successful, but if you run some command is failed, Okay, here you can see any number apart from 0. So 0 always be successful. Any other number come apart from 0 is fail. Okay, similarly, if you go to grab command, so abhi is not there, they show some other number not for 0. But if you search for Vimal, they will show you 0 here. Okay, and now why is important? Because in my pipeline, we are running this command. Any command you run, any program you run, if program runs successfully, they give the success code. That's called exit code, especially in the next command line. That's called 0 here. And if 0 come up, it means this script runs successfully. It means this job run successfully. Okay, but if you run a command and if this command by chance fail because we are not able to find Vimal here, so in this case this job will fail. So let me show you what this can demo very quickly by single job. By single job. So I'm putting Vimal in this file and then I'm going to grab, let's say, Abhi in this file. So obviously Abhi is not there in this file and let me remove sleep here. Okay, so this will command will fail. They send the exit code failure and so that will make my job fail. Okay, so every program, guys, has a different way to throw the error. Okay, to throw the error. Okay, this is the Linux command. In the Linux command, and the script is the one who understands the Linux command. Okay, whenever they find the exit code apart from 0, they get the message internally called fail. And you can see a pipeline has been failed here. When you click on this link, they tell you this pipeline has been failed because the script failed. If you see in the pipeline, more detail, this job has been failed. If you go inside this job in the detail, okay, here they tell you they run this pipeline 70 seconds, 11 seconds they take. This fail. Why? Here this output you can see, and you can see this is failed maybe because of this line. Okay, so this is also one thing to know. And because something failed, we can do some actions also. I will show you what actions you can perform in some time or maybe next class. But let me do the this part what I was trying to tell you before this. Okay, so let me run one more code here, one more job here, and let me remove this part. Now what I'm doing here, let's say this particular, or let me also remove the sleep here. Okay, so this pipeline, so not pipeline, this job is building this file with content Vimal, or creating this file with the content Vimal. Okay, and this job is searching Vimal in this file. It means this, if this command runs successful or not, we are testing here. Okay, so let me run it. Let me run these jobs. Okay, the job run. Let me see the view pipeline. So 2 jobs are running. Okay, 2 jobs are running, and real time we can see running and running. Maybe we can check here. Both the jobs are running. This guy's core symbol, we can run, cancel any job at any point in time. If you think you need to cancel and to redo something, you can do it. Both the jobs are running right now. If we talk about running, this job is running. One is fail, guys, by chance. Okay, which one is fail? The job that is a name test is fail. We are running for this command. Grab Vimal is fail. Okay, but let me see the other job. Other job, this job pass. This job pass. Okay, now point here is, guys, why they fail. Other job. If I go to my editor, okay, let's see here Have you seen any error in this code? Okay. Do you see any error in this code? Okay. Why they fail? Okay. Why this job fail? Technically, if you try to see, it don't look like any error in this code. Okay. There's no error in this code. If you see here, we have two jobs. Okay. In this job, this line is actually creating a file with this name, and this line is checking doesn't file we have this content. Obviously the content is already created, so it should show the successful, right? It should show the successful uh, over here. Okay, this is just work, right? But technically this part is successful, there's no error, but here this part is failed. That's what this job was talking about. This was failed. That's why I showed you already. Why the fail? Okay, it should be, technically it should be right, because this file and this file same, and what content we have here, same content we are searching here, do we have or not? So this should run, right? Why it failed? Okay, so idea, guys, is very straightforward, but very much useful. In upcoming classes we will use this idea a lot. Okay, so I told you, okay, whenever you run a pipeline, be inside the pipeline you create a job. In our case I have two jobs, job 1 and job 2. Now important point, guys, here is every job will run in their own respective runners. So this job will run in different runner, and this job will run in a different runner. Let's say runner number A, runner number B. And what I mean by runner, okay, this job will run in different Docker container, and this job will run in different Docker container, I mean like a different OS. Okay, even though we see here in this pipeline, okay, in this pipeline, even though not from exactly from here. So in this pipeline, whatever you have, sorry, in this pipeline, okay, when you see the field, okay, this particular job, first one who passed, it run in a runner. So guys, runner we give job for job 1. For job 1 we have this runner, and if you see here, the runner have a number FA in the last. Okay, but if you go to other job, this is one the job to pass. Okay, and if you go to other job, in the pipeline who fail, this job run in a different runner. Actually, guys, this is actually the ID of the run, but technically they run on the different runner. The best way to check is the container ID. This was not the better way to check. You can check the thing from the ID of the container. But technically, both will run a different runner, or maybe here also you can say the name is a different name. Okay, so point here is they run a different runner. Technically, runner is just a program, and runner is the one who will launch Docker container behind the scene. Okay, it means, okay, this code run in this container, and this code run inside this container. Okay, it means this file is created inside this container, and now we are running grep command in this container, and obviously this file is not exist because in this container is a different OS. We doesn't create any file hello, so obviously this create command will fail, right? They do contain these two different OS. Okay, and that is reason, guys, the fail here. Okay, this fail, this file not exist. What you're looking for is not exist, so they fail. And whatever, guys, the whatever the pipeline will be, you can go and check this will fail because of this. So, so what I'm trying to tell you here is, okay, so this is a very common thing, guys, in one pipeline to create multiple jobs, just to separate multiple different things. Maybe one job duty is to do building, other job duty is to testing. I want this job be running alone. I want this job to be running alone, because for building we need a different operating system, different RAM, different CPU, different Docker image, different uh, software tools. For testing we need different things. Okay, so in the pipeline for building, I might need different. I need a mostly a different environment, and for testing I need different environment. But there's something that is common between build and test. Okay, the thing that is common between build and test is this file, for example. Okay, so I want whatever file they build here. Okay, in this building. Okay, right now this file is normal text file. I'm creating here is called building. Okay, or maybe in Java code we compile and create a package. There's also building. So area to area, example to example, what you do in the building is different. But let's say this file is built, and I want this file to be transferred here. I want this file to be transferred here. Okay, how can we transfer? It is something like this. What a file I created in this container, I want to transfer in this container. Then only we can test, right? This has been done successfully or not. Okay. So here the role of artifact come into play. Okay, we have to tell in this build process. Let me take this example or this diagram. Okay, so we would be very clear. Okay, in this two jobs, okay, let's say again for simple reference, this job is like a build job, or this like job is like a build stage. Also, you can use the term here, or this is like a test job. Okay, this is running in a different operating system. Let's say operating system number 1 or Docker container 1 or Docker container 2. Okay, so if you want to pass any file, OS file contain data, okay, between one OS to other OS, and from one stage to other stage, one job to other job. Okay, so how can you do? So you have to first check which file you're looking for. For example, I want to send this file from here till here. Okay, so in this case, what you have to tell the GitLab do one thing. I know whenever you run a job, you run the Docker container. After the job run, you remove the Docker container. Means whatever data you have inside Docker container, you remove it. Even though if you see here also, when they run the job in the pipeline, either pass or succeed. Okay, in the last, they clean up everything. Clean means the container they launch, they delete it. Okay, it means whatever they are doing inside the container. Okay, maybe running some program, installing some software, creating some file, installing, creating some packages, by compiling, everything they removed. Okay, so maybe some part might not be important for me. I don't want to keep after they remove the container, but some part may be important for me. So in this case, the printing this message, right, might not be important for me. I can see in this kind of black screen. But when they create this file, this is important. I want to keep this file with me. Maybe I want to use this file somewhere else. I want to share this file to somebody else, or I want to send this file from here till this job, whatever the case would be. Okay, so you tell the GitLab, this file is important for me. Can you please archive this file somewhere, store this file somewhere? So for this, you will tell the GitLab, for this file is my artifact, artifact. Okay. And when you tell this file to the GitLab is my artifact, automatically they will archive this file. Archive means they save this file somewhere else. So after this job, the job completed. Okay, that I made this OS, I made this container, but this file with the respective data will be archived, will be saved somewhere. So you can use somewhere else where you want to use it. Okay, this is also guys one of the example of the artifact. How can we do this? So for this in my editor, okay, editor, we can tell that that in this particular job we have want to do something to be artifact. And guys, here all the commands support, they automatically show you automatically when you type in this keyword. So I want something to be artifact. And some by default example they already created. Let me remove it. I don't want in this case. So I can say I want something to be artifact. Okay. Which part you want to artifact? So do you want this file? Right. Obviously, there's no meaning to archive the command. Command is a program. Program will run and they put the data on the top of RAM. We always artifact the thing that is there in the hard disk. And hard disk, we have the files. So do you want to artifact this file or do you want to artifact maybe other file? Okay, let's say my.txt. Which one you want to artifact? So both. Okay, or maybe you can also plan in this way. Okay, those files that you want to artifact means you want to save it, archive it. You can create a proper plan. Maybe I can create one folder here, let's say build folder or my build folder, whatever I'm going to give. Okay, all the file that you feel like that you want to be to artifact, you can store those files in the build folder by giving the path. Okay, so first we get this folder. This file I create inside this folder with this content. This file I create directly in the current file system, is current by default root folder. Okay, so some file I have in this folder, some file I have other folder. So in the artifact, I can very quickly say that I'm going to give you a lot of paths. Okay, the path is my build. So any file that in this folder that I already have, either created, you already have in your container. Okay, I want this file and all the file in this folder to be artifact, or maybe give a file name also. I only want this file to be artifact. That's also can give. Okay, so planning would be guys again very proper, because when you building something, especially in the container world, the container quickly launch, we do something, and after we build or maybe test, we remove it. There's normal practice we do in this kind of CI/CD. Okay, so an entire process, maybe some other part might not be important. Printing something, mailing, installing software. Okay, that we can do again one more time. But if you're creating something, creating some data, creating some software to compile, okay, so if you need some data that you want to be stored, okay, so you can use in the future, then you can use artifact keyword and tell which folder and which file you want to artifact. So here I'm giving the entire path, all the file in this the job to be artifact in this folder. In this folder from the job to be artifact. Okay. Now in this context, okay, and let me commit change. Okay. Pipeline again run. Let me see the view pipeline. Okay. Job number 1 is running. And guys, here they succeed, but you will see one interesting option here. Okay. After this job run, they run the artifacts. And say in this job, we have to do artifact and they upload this folder somewhere. Okay, somewhere. This folder with the water file we have total 2 match. Why 2 match? Because in this folder, In this folder, one we have the folder and plus one we have the file. Okay. And after your artifact, automatic in this page, you said get this option. This option was not there, but you get this option because in this job we artifact. So here we can download also whatever artifact, or you can browse also. Now see here in the browse, this is a folder name what I artifacted. In this folder, this is what the file we artifact. And this file, if you see, okay, this text file, this is what the content I file put in this file automatically save. So even the job completed, okay, but you won't lose your data. The job completed. In the job, your Docker start, they run some program, do something, then they deleted everything, they clean up, but your artifact will be there. Okay, and this one thing. But if you talk about the other job again fail. Why? Still they're not getting this file. Why not getting this file? There's more reason. Let me fix this. Okay, because I created my my artifact in this folder. So while testing, you tell this file is you have, but it is there in this folder. So by creating this file or by building this file, I keep this file in this folder. Luckily, we artifacted. So other job can use this. Okay, so the same folder, you have giving the location here, and I'm just checking this right now. I think this thing is right. When I commit, the job run pipeline created, and let's see what the status would be. Again, guys, this failed. This failed. Now, why they fail? Why they fail? The one reason of failing of this job, technically should work. Okay. One reason of failing this job because of one reason. Okay. But right now, this job is running in parallel. Okay. Parallel means both the run parallel. This also run parallel. This also run parallel. This can also run parallel. This also run parallel. It means both the jobs run parallel. And our challenge is, if both the jobs are running parallel, okay. Now, in this case, this job, let me give the job name A and B. B is the job is purely dependent on A. Okay. And but they are running parallel, means A also run, B also run. Or maybe A might take 5 seconds to complete. Okay, complete means run all the command and copy the data here. Okay, and B might complete 1 second. So as soon as B run this command, okay, this operation is still going on. Okay, they don't find this file, and they quickly fail. Okay, because this operation will take might some time to copy here and there. So point, guys, here is, okay, in some cases running the job in parallel might make sense. There are some example I'll tell you tomorrow. But in this example, especially build and test, only we can do build. Okay, after build only we can do test, right? We can't do that test directly. First my software compile, then only we can test. After compile, then only we can run and test. Okay, so build and test is something where test is always depend on the build. If build doesn't complete or build fail, there is no meaning of test. Okay, this is sequence. It means you have to run your, in this example, you have to run your job in the sequence, serial, one by one, one after another. But by default nature, guys, of this particular of this particular pipeline, they run all the jobs in the parallel. Sometimes very useful, but in this case, it's not useful. Okay. So how we can make the job run in sequence. So for this, I want to tell you one small thing. Guys, when you create a job, in the job, when you do something, everything you do in the job, they give a stage name. So we go to pipeline. Okay. This pipeline that you see here, or maybe the jobs you see here. Okay. Then this job, they give a stage test and test. So there's a by default job stage name they give you that you can change. Okay. And by chance, both the jobs, see 97 fail one, 96 pass one. First one is pass, second one is fail. They give some internal numbers. Okay. Both the jobs have the same stage name. Okay, test. But let me change the stage name. How? Let me change the stage name. Why I'm changing? There's some reason. Okay. So let me give this job. Inside this job, let me create one stage with a keyword called stage. Okay. Let me give the stage called build. Now this job, we have one stage called build. Under this stage, under this build name, you can give any name, doesn't matter. They will run. And in this job, let me give a different stage name. Let me go for test. Okay. Now both the job have different stage name. Now what happen after do this? Okay. Now again pipeline run. Okay. Now here guys, if you see this 2 arrow gonna come up. Last time it was 1, but because we have 2 different stages, now they said this is the stage build is running and the stage test is still created. Okay, it's still created. And if we click on the pipeline also, you can see they're running completed, then test run. The test run. Okay. So my point guys here is last time, because both the job by default has the same stage name, and whenever you give the same stage name, okay, because they think they're the same stage name, so automatically they run the parallel. But as soon as you give a job a different stage name, so they will run one after another. Okay, so first they run build and they run test. If you click on the test, last time it failed, but now they run very much successful. This is one thing. Okay, let me go to editor. And the sequence would be, guys, in the code, whatever you write first as the job name, they will run first, and what you write in the second, they run as a second. This is by default behavior. But you can change this behavior. How? We can write some kind of global setting here. Global setting here. In the global setting, we have one keyword called stages. And here we can give a sequence. So I want build to be run first, and then I want test to be run. So that's also we can do. So wherever you find build stage in any job, run first this job. Then after build, run completely. Then wherever you find test stage job, then run this test stage job after this. Okay. So even though you can do vice versa also, we can write top test in the top, then build and more jobs also. So this also you can control. We can add more options also here, more condition also in the upcoming classes. This first class, I'm trying to give you a core idea and some feel of this graphics also. And now if you click on the visuals, these are 2 jobs. You can say build and the test job in this sequence. We can see here. And now if you click on commit changes, something has been changed. This you can see this icon come up, view pipeline. You will see this job is still here. It's just created, it's not running. Okay, this is running. After this job run, then only after build completed, then only test will run. Okay, so sometimes sequence running the job in sequence makes much sense. Okay, and this here after this completed, then this job will run. And sometimes some example I'll show you tomorrow. having the job in parallel, or we can do mix, or sometime run something run in sequence, something run in parallel. Both the things will work over here. Okay, so this is running it completely being done. Okay, so this is some few example. It just a quick start of creating the pipeline, but at least you see what GitLab is doing. One thing you see is if you're using Jenkins or any other tool, okay, then you have to create your own Docker environment, connect the Jenkins with the Docker, again do the remaining management part of it. But here that is already been given to you. You have to actually use it. Okay, that's what I'm talking about, guys. One single DevOps platform. This is one example. Otherwise, there's tons more things we can do on the top of this as we progress in this program. I will give you a lot of more knowledge on it. Okay, so this is a very basic initial pipeline as a code. Tomorrow, guys, I will go more deep into this, and tomorrow we will see. Right now, they're using a Docker image called Ruby, but if you want to change the Docker image, why you want to change the Docker image? How we can deploy some application. For example, tomorrow I will show you if you want to host some web application, maybe let's say written in Node. So how we can launch and host the Node application here and build the pipeline for this. Okay. And more example you see, you become more comfortable with the concept of pipeline as a code. This is called pipeline as a code. So I write a code to getting pipeline. Okay. Plus some more basic and advanced concept I will cover too. So that's all, guys, in today's class. And I just want to conclude. Any query if you have, you guys can ask. Okay. So any query if you have, you guys can ask me. By default nature, see Hari, I think that's what you're talking about. By default nature is running, and this nature is coming because of the staging. If you give 5 jobs, same stage name, they will run in parallel. Okay. I'll check, John, if you can show this example, because there's no meaning of Ansible here, technically. Okay. Ansible is useful if you want to do configuration management. Okay. And we do configuration management for that environment where we are managing the infrastructure. Right. But here we are not doing any infrastructure management. We are not configuring any Docker or any system and operating system. Is a platform given to us. Okay, so there is no great reason to use Ansible here. Even though we can use somehow, there's not big deal. I can launch one Docker image with Ansible pre-install and run my Ansible scripts here. Okay, or maybe I can run my some Ansible master node. Technically, it's possible. I'm not denying it. We can't do it. We can do it, but there's no good reason to use Ansible here in this kind of examples, because we not need to do any configuration management. Instead, we have pre-created Docker images for our environment. Okay, and those Docker images will actually use to build and test and deployment other things also. Okay, I think that makes sense, John. Or if you have some specific use case, you can tell me. I will definitely try to show that demo. Yes, Ketan will talk more about it. How can we set up multiple stages, or what's the plan that in one job we can have multiple stages or not? That what some of the discussion we're going to do tomorrow. Do we need to learn Git and GitHub for this? Sriman, especially for this part. So when I talk about the repository part, this repository is more like Git and GitHub. Okay, so whenever I need, I will quickly use it. Okay, and then if you know Git and GitHub, you will quickly understand what is going on. Okay, So even though if you see here, when I'm writing something here, they keep on committing, right? So this commit is exactly like creating versions in the branch. Okay. So if you know about branching, merging, committing, comparing, uh, that will give you more information about the managing this code. Okay. So that is one of the reason I'm asking you if you guys uh, can learn, get on GitHub. I think we have already provided videos to everyone. So Jacob, we will talk about the user role. Okay. In the user role, we're talking about uh, role respect to GitHub, right? And I don't know what you're talking about runner. In the runner, they are running the command with the power of the root level. Okay, or we can change also. Okay. Um, in the Docker image or the metadata of Docker. But if you talk about user role with GitLab, we have a discussion on the user role we'll talk about. So Kelly, you can connect to our admin team for if you miss some part, we said you joined 2 hours late, so they will definitely help you. Okay. So in your WhatsApp group, you will find the admin number, you can contact with them. So Raktim, you said once 2 years back when I started learning with you that job will come to you. Today is actually happening. Right now I'm doing Capital One Bank, IBM project, 14-year experience guys from US, and biggest thing I'm teaching him every day, DevOps and cloud. Thank you for this. I think very, very proud of you, right? as a student, if you are a lot of experienced guys are learning under you from the multiple companies and the countries, it's very, very proud moment for everyone. So great and all the best. Uh, Yes, Alekia, I'm so sorry if you're not able to pronounce your name properly. By default, they use Ruby, but I'll show you tomorrow class. If you want to change the Docker images, and actually we have to change it due to a lot of reasons. So that was one discussion we will discuss tomorrow. Okay. Artifact Saurabh in Git lab, it is same thing that you do in the Jenkins. If you know this concept called Jenkins job post build, and there's also called archive artifact. Okay, that is same concept. Over here we have artifact in GitLab. So, John, this is about security points. We have a discussion on it. Some kind of this scenario I will talk in my, not this tomorrow class, but maybe in the third class I will talk about this. So, Simon, right now your Node and Express class is going on. After they complete, then we'll start the React. But the code concept of React, CSS, JavaScript, HTML, we already cover in your classes. So covering the React won't take much time. It's just a framework. Okay, base will be HTML, CSS, JavaScript. That concept you know, so it won't take much time to complete. Yes, Lakshya, I will talk about on-premises GitLab also and how to run the runner and executive pipelines in upcoming classes. No, see, Hari, right now, this YML file is just for syntax. Script is a keyword for running the next command, but we can do much more thing also. And this is just to be started today. But what else we can do? What are the commands and keyword available? We will see in the next class. But this is only for the next command or the next scripts you want to run. If we can change the Docker image, others, that's what we is one of important discussion we will gonna do, and why to change and how to change will also do. Yes, or we can write HTML. HTML like a normal text, right? You can just type it. So when you type something here, it's become your HTML, right? Nothing very technical. HTML is like a normal string, right? Put in some file, and this file you can host with your some web server or some other example I'm going to show you tomorrow for this, but nothing very special over here. Need to practice some communication interviews. I think Himanshu, we have conducted multiple sessions on the communications from our side for the art students especially. Okay, I think multiple sessions, and even though from Indian platform, Sadab also connected multiple times, and I think they also keep on asking you for you guys any challenges you're facing in the any interview problems, right? They are trying to help you. I don't know, have you know this or not? But let me ask my team. They will again do some plan if possible again to do something, right? So I'm not committing right now, but we're trying to have some more thing for you about especially for art students. Is Kelly, I'll definitely think for AWS Amplify as a future plan for future course, right? Can we run multiple job in single container? Answer technically, Bhumi, by default job will run in one single container, but whatever you want to run, you can put here, right? So just put all the command here, that's all. So running multiple job in one container, it equals to running all the command and put here. Same thing, right? But by default, creating a job means we are telling a signal to the GitLab that I need one executor for this, I need one executor for this. Okay, but if you have any specific use case that you want, you want that both the code run in one single container, put this entire code, copy and paste here. It will be the same thing what you're looking for, right? So that's all, guys. See you. I think this is the first day of the GitLab, multiple core concepts and some of the practicals we have discussed in today's class. Go and create the account in GitLab and practice at least till this code. I'll share this code. We create a separate Google Drive link for you and entire data. Entire data we put in GitLab. I'm sorry, not GitLab, Google Drive, and we'll share with you in respect to WhatsApp group. Okay, so that's all. See you guys in the next class. Bye. Good day and take care. See you.